Welcome again, and we will start with the second day. As I promised to you yesterday, we want to give you a very short presentation where you are, where we are, we are, and what we are doing. You are visiting us, you are our neighbors, huh? And you have 40 years in front of you, the university probably hundreds, huh? And we want to collaborate. If we don't collaborate with our neighbors, with whom else? Huh? So, therefore, just a very short presentation, a couple of minutes to show to you who we are. The Cyprus University of Technology, established in 2004 below, 2007 with the first enrollment of students. With other words, we are below 20 years old. It's an anniversary year this year. We have more or less 3,000 students split in 8 faculties. One of them is the engineering, under which there are 3 departments. One is the electrical engineering, computer engineering and informatics, in which I'm coming from. The second one is the mechanical engineering, mechanics and materials and all these kind of things, out of which my colleague Petros is coming. He's going to introduce himself later. And the third one is the civil engineering, geoinformatics and all this stuff. A third colleague is going to join us very soon. All these 3 faculty of engineering, all these 3 colleagues, myself, Petros, and Athos, we're going to join us working together under the UNESCO chair. Okay? Doing what? From the space down to the ground, digitization, as it is also well written in our Bible, in our contract, in our project, okay? But not only for virtual exhibitions, for the great challenges of the humanities which we have in front of us. And which are these? Protect, preserve the past, identity, this is also very important for you do here in this region, and monitoring of what exists now, climate change, natural disasters, human disasters, and all this, So therefore, this is extremely important. Documentation, but to do that, we need to introduce it how? Exactly the same way as we do in CREAMS in our educational system. Create syllabi, curricula, establish lectures, running other training activities, being involved in EU projects, and here we are. We exist as a lab since 2012, 2013, the year, as I mentioned yesterday, when Cyprus declared bankruptcy. Okay? The day when we were out of money, we established the lab. No guarantee that we will be successful, but at least we had, and that's very important for you, for your future, we had one privilege. They say to us, do whatever you want to do, blue sky, okay? Be totally independent, take into consideration the legal framework, be careful, and try to do your best. If you manage to survive in this catastrophe, then it's good. And we managed to survive, and we managed to bring even the UNESCO chair, and then the ERA chair, the European Research Area chair, to Cyprus. Plus, here you can see 27 million euro came for the university 2 years ago. That's the statistic. Now it's almost 30 million euro. Okay, 20 years the university exists, 30 million euro. So the lab exists 11 years, and the lab managed to bring 11 million euro out of the 30. So this is 31%, more or less, of the budget coming from the EU. And we are totally independent, financially independent from the university as well as from the Cyprus government. We never received even 1 cent from their budgets. And we are very proud of that. and that's the way of how you have to work also in the future. Be, so far as concerned, professionally, but also financially independent. If you manage that, you are the winner. Okay? So now, if we see now how this budget was distributed in Cyprus, Cyprus managed more or less 300 million, and we, you see here, 3% of the national budget coming from the region. So Rebecca knows that, your supervisor knows that. We have every year, or not every year, now it's every year, but it's a biannual conference, the Euromed conference. Our publications are always by Sprinkle. You've got a copy of that for your library. And we digitize. We digitize because the number one now under threat are the monuments, are the artifacts and so on. We digitize monuments, any kind of monuments, religious monuments, archaeological sites, medieval, whatever, yeah? We don't care the type of the monument or the time that it has been created. These what you see are unique, but different type, yeah? And all handmade monuments. This what you see here is Neophytos, yeah? Neo, sometimes they say the name. Son Neophytos is a Cypriot. And here is where he spent his life, in a cave. It's 1,000 years old cave, but it's under threat at the moment, a high risk. So, the one monument that you saw is the Castle of Paphos, UNESCO World Heritage Site, very famous, different kind of monuments here from around Limassol and so on. I will move a little bit further because those are the, here is a nice one. Castle is not so far away from Limassol. You know that Cyprus in the medieval time period was in the Middle East the #1 country producing what? Sugar. Now we don't produce even 1 kernel. Yeah? Not even one. We import that. That's globalization. Huh? So, and that was where the production site was here by Limassol. So, anyway, let's catch up a little bit. So, this what we are doing, and here is where now, just a second please. This is what also the project comes in. We started digitizing, but not only monuments. We digitize also photographs. Yeah? Photographs, why? A photo is what? 1,000 words, huh? It's a book, huh? So, has a story to say. So, having that in mind, here we are. Behind us is the memory of our parents, in front of us are the eyes of our children, and again, with the full financial support from the EU, what do? We went and we asked the people of Cyprus, you have albums at home. Even you have albums at home, yes or no? Each house has a, this is your first treasure, #1 treasure. And this is what? It has been handed over from your grandparents to your parents, and so on and so on. Or aunts, uncles, and so on. It's a piece of memory. You have to preserve that, yeah? So we ask them, share your photos with us. We will scan them. We will give you a digital replica, okay? The digital twin. So, if now we get also the story about the photo, what do we have? We learn the distance. We have the memory twin. Huh? So, digitizing the photos, having them available on internet, we share them with Cyprus, with the rest of the world, and with the rest of Europe via the European Union Library Europeana. Yeah? And voila, this is what you see here now. It's not anymore in our life. Again, this very famous and well-known word, globalization. It's gone, it's over, okay? And of course, forward. Cyprus was also involved in the Second World War, several volunteers, yeah? Outside of the council of the building, there is a bomb. Yeah? One of the first from the Italians, when the Italians bombed Limassol. So we are working with local authorities, more than 150 villages, municipalities, regionally. You see here, Bank of Cyprus, Ottoman Bank, Bank of Larnaca, only the Bank of Cyprus exists, nothing else. So, and now, again, tradition, yeah, intangible. All this, but whatever we digitize, it's under one precondition. And here it comes again, IPR issues, yeah? IPR issue. You have to pay attention that the content is IPR free. Why? So that you will be able to share it. Okay? Bible is the #1 published book around the world. Why? Because there are no copyrights. If you want, you can republish it X times. Yeah? So now, that was about us, about the small lab. We move to the colleague who is going to give you now, if and in case we digitize something, if and in case we, and this is a tangible object. Now we are coming to the CREAMS slowly, in this direction. We want always to be sure that this, what we digitize, is correct, is exact replica, and not only exact replica, that it's a functioning replica. Functioning replica is not to take it and visualize it, exhibit it, and so on. No, is to reproduce it, to have it ready to go. Why? Because we need always to be sure that there is exact copy, a real exact copy of the original. So, a certified one. And for that we have our colleague, you have to share your screen, we are in Zoom.
Lecturer at the Mechanical Engineering Department, and I lead the Mechanical Engineering Design and Additive Manufacturing Lab. Additive manufacturing, fancy words for 3D printing. And that is what I will be discussing, the role of 3D printing in the digitized or digitizing cultural heritage. So in a way, it's kind of the future of manufacturing applied in our past. No need for me to emphasize the importance of preserving our memory. It is in part protecting our identity. I'm preaching to the choir. You all know how important it is to digitize and preserve our memory, our monuments, our artifacts, against degradation, conflict, climate change, and just simply time. So the role of digitization in heritage preservation is obviously to conserve, to provide accessibility, to use in education, to use for restoration, and even tourism. This is an example of a digitally repatriated artifact that I don't know if Marinos has told the story from Sweden, from one large collection of Cypriot artifacts that is residing in Sweden at the time and has been for a long time. So this was kind of digitally repatriated in the sense that Marinos went with some students and scanned and brought back the data.
This is what we want to do with the CREAMS, but not now, later after the CREAMS is over, because we don't have the content yet. In Stockholm, in Sweden, it's hosted the largest archaeological artifact collection of Cyprus. Can you imagine? 60,000 objects. This is what we want to do. is a virtual exhibition using the content from where? Metadata certified by the owners, and the owners are two now. Legally talking, the Swedish government and the Cypriot government. Approved from both of them that the content is correct, the story there is correct, and exhibited. Making it available for everybody, not only for students to do whatever they wish to do, okay? But also for tourists, for professionals, and so on.
So it is, if you have in mind the Terracotta Army, that was in China. So this is kind of an equivalent and similar.
Yes.
So there's a lot of terracotta statues, and it's a huge collection.
Over 10,000 terracotta soldiers. Can you imagine? There are two worldwide collections. One is in China and one is Cyprus, but it's not. It's a Cypriot one, but it's not here. Partially it's here. The biggest part is in Sweden. We want to reunify them.
And many Cypriots don't even know that
Yes,
exists.
exactly.
Anyway, that was during the British colonial times. It's a complicated story, but anyway, this is
you have the most
digitally repatriated artifact. Now, this is only digital that would show. So we are using 3D printing, also known as additive manufacturing. So what is that? That is a manufacturing method that is basically adding material layer by layer and thus producing a 3D solid structure. That is as opposed to subtractive manufacturing, which is most of the classical methods where you start with a block and you remove material to leave your structure. That gives a lot of potential to how you can use it. So why is 3D printing, how does that integrate in digital heritage? So when you have a physical object and then you digitize it, then you have it in a digital form. That is data, that is a cloud point. So you went from the physical world into the digital world. And when you show that in a 2D screen, it's 2D. Even though your brain thinks it's 3D because we trick our brain to think this is 3D, it's actually 2D because it's a 2D screen. So from the digital world, 3D printing is a way to bring it back into the physical world as a 3D solid object, like in this example. Also, with 3D printing, it's a good method to test your digitization, to see whether the data acquisition was done properly, whether you have no gaps. Even though sometimes you might digitize something and it might look alright, when you really look into it, it might not be. This is an example of the previous building that we saw, a church, and you can see all the problems that exist in the geometry, even though it looked fine. So it's a good way to kind of test your data and see if there's any parts missing, or if you have to go back and redo some parts. That was particularly useful in the Swedish mission, where there was only limited time to digitize artifacts, and those artifacts had to go back. It's a very strict protocol, so you have to really check that you did a good job before you leave the premises. So that's a way to test it. Also, with 3D printing, you can do a number of other things, like you can do restoration, you can do representation, replication, even innovation, and we'll see what that means. So when you're dealing with real artifacts, you can really handle them, you can touch them usually, and you have to be very careful when you try and restore them. So 3D printing offers some good and interesting solutions. For instance, restoration. If parts of some tangible object are missing, then you can use the existing parts and kind of try and restore it. You can do it in a way that is obvious that it was restored, because archaeologists don't like to mess with the real artifacts. So you can clearly tell which part was restored and which part was not. But you can do that, and you can do that quite exactly, because this manufacturing method allows you to do detailed work in kind of these organic shapes. So complex shapes, it's an ideal manufacturing technology for producing complex shapes, like the hair or the eyes or all that, which would be more difficult to produce with traditional methods, at least one piece. This is another example of a different kind of object, is the Buddha, and they restored a lot of it that was missing using 3D printing and 3D scanning, combination of these tools with CAD software, and you can do that very nicely. Another thing you can do is offer accessibility. Now, if people might have visual impairment and you take them to a museum, then there's not much they can get out of the experience. However, if you 3D print something, either in real size or in scale, then they can touch that object, they can feel it, they can employ their senses, and then they can experience artifacts that would otherwise be inaccessible to them. This is an example of a scaled down amphitheater or a one-to-one scale pot where the drawings have been kind of extruded, so creating a texture that somebody can feel. So people that wouldn't otherwise have any experience or idea what you might be talking about now get access, and they can obviously not touch the real object, the original, but they can touch and feel and experience the replica.
If you allow me, just only here, Rebecca, for our project, for example, one of the greatest challenges existing is how can we manage to give access to people who are blind? How can we manage to give access to those who cannot hear? Let's say how we can give access, and so on and so on. So there are different groups of people, okay? If we like it or not, that's the nature, part of the nature. How we integrate them. And this is one of the greatest challenges, and especially on our side, in Cyprus, if we work and we are financed by the EU, we have to take that also more or less into account. If and in case we apply for the EU and we don't have, very simple one, and this is the example, the gender issue, with the gender issue is not only male, female, everyone, on a universal one way. So then there is a problem. You know what? You failed. By the submission of the proposal, you failed automatically. No success, no success. Even if you have the greatest out of the greatest innovations proposed to the Commission to be financed, you will fail. So therefore, the inclusion of these people, it's extremely important. Have that in mind. We are talking now to people who have 40 years at least in front of them to work. Okay? And something which is important, and I want to underline, if in the case you take it into consideration, and it was not a precondition in whatever application or work that you created, everybody who is going to see, feel it, experience this extra added value of your work, including these parameters or these groups of people, they will respect it. They will, say, wow, that's great work. So, sorry.
That's right. And then replication. So this is an example of a good use of it. It is the statue of Michelangelo's David that was 3D printed and sent in Dubai. Obviously, it would be very difficult, impossible, to move the real statue that bears so much significance and importance to another place. However, you can transfer a replica, a faithful one-to-one replica that can be there to promote tourism or culture and kind of invite people to see more of it. So this was done here using 3D printing. I won't bore you with technical details. There is essentially three main, I would say, 3D printing technologies. The fusion deposition modeling, which is the one on the left, where material flows through a nozzle and is deposited layer by layer. The SLA stereolithography, where you have a beam of light or laser that solidifies a liquid, otherwise resin, and slowly builds the solid from the liquid. It emerges up as a 3D solid. And then you have selective laser sintering, which is a volume of powder that is solidified by a beam of laser, and then slowly builds up the solid. And then there is multiple various combinations of these main technologies and plus some more. Each one has its own benefits and its shortcomings in what it can do, how accurately, and what kind of pre-processing and post-processing you need to do. For instance, overhanging surfaces, supports, and so on. Some case studies. This is an example of an alleged baby bottle that was found in Cyprus. 3 of these were found in what was presumed to be the workshop of the craftsman. And CT scan was employed to capture internal and external geometry. This is an example where there is an internal structure, but obviously you cannot access that with the original. So CT scan offered this capability, and obviously it took some processing. The data, the 3D data that were originally produced were not sufficient to 3D print it, so we had to go back, get the raw data, meaning the slices, and then we had to reconstruct again the 3D structure. And from that you can obviously see visually some stuff, but also you can then create the solid and 3D print it in any way you want. You can open it up, you can cut it in pieces, you can make it in a way that you can explore maybe how the artist created these artifacts. You want to say something?
Yes. Can you guess what is this object? What was the function of this object? This object is 2,500 years old. It's a Cypriot wine.
It's a baby water bottle.
It's a baby bottle. He said that.
Yes, I gave that away.
Sorry.
That's all right. Yeah, but you could have cheated. I wouldn't have said anything.
Yes, a baby bottle. It was at the same time a toy to play, the baby, to concentrate, you know?
There is some discussions as to whether it was actually used to drink milk or it was a toy or kind of a thing that to pour some liquid. But yeah, it could have served all these purposes.
We did a real investigation. We took even samples from the interior, yeah? We sent to California in America and we had a chemical analysis, so.
And it was milk, it was.
Yeah, some.
Traces.
Yes.
Yes. So this is some examples of some considerations that you have to take into account when you. So this was printed using photosensitive resin. So there's a pool of liquid that with light it solidifies, polymerizes, and then slowly this builds up. You're going to see the video. And there's things that you have to take. You have to support certain surfaces. You have to be careful that resin doesn't get trapped and then blows out and destroys the artifact as it gets printed.
For Marios, extremely important always to think on at the end of the pipeline of the CREAMS, the virtual, the augmented, and the real, how these objects can be used or reused, okay? Because those are the artifacts to be delivered to the CREAMS pipeline. Now, voila. Here.
So this is it being printed. So down you can see is the liquid resin. And then it's attached to the plate that is lifted, and then there's a laser going around and solidifies parts of it. So, and then it emerges from the liquid. It's quite nice. Takes a long time though. It was, I think, around 12 to 19 hours. And then you need to do some post-processing to clear the resin and so on, remove the supports. And here it is, as it is also artistically constructed. So this was given to a professional painter and kind of applied colors and the texture and the visual texture to restore it as it was. So on the left you can see the original, on the middle you can see how it was 3D printed, and then you can see it painted on the right. There is capabilities now to print in color as well, quite expensive, maybe different kinds of materials, there's other issues there, but it's getting better. Also, I mentioned innovation before. So let's say that an artist wants to play around, combine the new with the old, try new things. You can take this and then you can process it in CAD or in any other digital software, and you can make something new. You can make a modern baby bottle based on this. So combining the old with the new and doing something great. This is a large-scale example. This is the castle that Marino showed before, the Paphos castle, which was also digitized, and then it was printed. So we tried to see how small we can get with something that big. The material used here is a kind of a semi-transparent, so you can also, if you put it in light, you can also see the inside structure, which is a nice use also of the 3D printing capability and the use of materials at a scale, which is something you can do in the real life. Also, you can see some details, sub-millimeter detail of there was kind of this mesh, old mesh, I think broken, and it managed to capture then the little stairs there. Some more examples of the Swedish mission. There was a live link between Stockholm and Limassol where the data were being sent, checked, and then we were printing to see if everything went okay. This is some of our new equipment. It's a 3D scanner, uses three different sensors and sources of infrared, and also is able to capture texture. Now the future, as I mentioned, you can 3D print color already, and you can also 3D print in higher detail. So if you capture texture, you can actually print it in very fine detail. This is two examples of Van Gogh's work, and you can even, this was 3D scanned and then 3D printed, and you can see that even the strokes of the brush were captured in this work. This for me. So 3D printing offers some interesting and promising potential into digital cultural heritage. You can mix the old with the new, produce new art, produce designs and innovation. You can access fragile objects that you otherwise wouldn't be allowed. You can use models for hands-on history, education and experience. You can combine it with a mixture of experiences, virtual reality, actual reality, and 3D printing. You can feel something, see something else, and be in a different space. And also 3D models are also for virtual and physical exhibits to be made accessible worldwide. Any questions? Thank you very much.
Thank you very much, Petros, for the very compressed, but also very nice, well done presentation. So that's now, this what Petros presented now, it's something which is accepted from the community. Which community? Not only the art, the creative industry, but also from those in charge of the content, from the archaeologists, from the museologists, from the historians, and so on. They accepted that in the meantime, and they want to have it. They want to use it, reuse it. And that's how we say now the automation is moving to the museum. And here is the added value of the project, where we see the extension of the project, including this kind of technology. So the use. Why to have it in a mixed reality at the moment when I cannot, what? 3D print the object, okay? Have a replica, a real replica in the hand. Petros, thank you. The connection of electrical engineering or informatics to the humanity. Again, the digital, digital humanities, that's where we come in. Then mechanical engineering, Petros, that's voila, all the pipeline that he presented earlier. And now, Athos, and he's going to give you a presentation and talk to you. Now need to link together is this what you do locally at your institute, within your course as a third-year student, CREAMS, and this is what you are now going to experience.
Okay.
Athos,
so,
close.
Okay, thank you, Professor Marinos, for inviting me here, and good morning to everyone. I am Athos, I'm assistant professor at the Cyprus University of Technology. So I will try very briefly. I have a lot of slides, but I would like to skip some of them. So I will really briefly, I would like just to highlight you probably a new.
You have to share your presentation. But you see the presentation of Hassas? You see the presentation? I don't know, Rebecca, are you? Not online, okay. Now he's going to share it. Yes, exactly.
Is that okay?
Yes, we see. About full screen.
It's a new feature that you can, yeah, on the Zoom, I think it is full screen, but
You just see
you want to see it.
So, okay, I will. It's a quite extensive presentation, but I will try to skip and stay to the basic. And I would like to talk about depth observation and remote sensing. Probably this is something quite new for most of you being here. Before I start, just to add on the presentation that Petros did before, and it was really nice and excellent presentation, is why is 3D printing important? Is not to forget the basic, because in order to have an accurate 3D printing, you need a 3D model. And we talk about precision, we talk about accuracy, millimeters sometimes. So this is really important because all these are aligned to international conventions, international standards related to cultural heritage. So it's not an abstract representation of a monument, of a tangible object and so on. It's a real representation at a specific point of time, as this, let's say today. And this is really, really important for protecting and preserving cultural heritage objects for the future generations. We are not creating a 3D model, we are not creating a 3D printing of something as we thought it would be, but it's on specific parameters, specific shape, color, dimensions and so on. So this is the basics, but we all have to keep in mind that we talk about reality and how a monument or a site exists in a specific time, let's say, in our days. So I have this overview. So I will try first very briefly to bring you into my world, which is about digital technologies and not observations. And in general, what we are talking about, we talk about these few bullets at the end of the slide. Our interest about digital earth, digital twins, if you are familiar with these concepts, and especially for satellite remote sensing, satellite imageries, and geographical information systems, GIS, probably you have heard that name, and of course global GPS, global navigation satellite systems. And there have been hundreds of applications of how we can utilize satellite data, satellite imageries for cultural heritage objects. So you can see different aspects of that. We will see more in details. And why spending time, why spending money for such a topic? Because it's a technology that is growing really fast. You just see here how many satellites are expected to be launched by the next 15 years. So it's a growing technology that will have a tremendous impact also in cultural heritage thematic pillars. And we are all aware of the big data and how we can, because we talk about a lot of data coming from satellite sensors, and so we have also this kind of awareness of how we can utilize all these different types of data. I remember myself 15 years ago that we were thinking that we don't have data, especially for archaeological and cultural heritage applications, are not enough for specific things to do. But now we have come at the point that we have a lot of data, such as satellite images, close range photogrammetry, and so on. So we need another way of thinking of how we can process and how we can manipulate all this data for the benefit of protecting and preserving cultural heritage data. And just a hint, we don't talk only images, satellite imageries, as you will see in Google Earth. Probably you have seen this many times, or also in mobile phones. But they also exist satellite videos. Okay, you can buy satellite video monitoring a specific case study. It's quite expensive, but it's there. Just 20 seconds just to see. So this is satellite video. It's a satellite sensor out of orbit, and now it's capturing at 1 meter the resolution of something. Imagine that we can capture this image all over the world, even in areas that we cannot go there to visit. Either we have conflicts, either we have any hazards, and so on. And once you have this video, once you have the satellite, then you can do a lot of things of monitoring and protecting. So very, very briefly, just I would like to go directly to the examples. Satellite remote sensing or remote sensing archaeology is not a recent topic. It's not something that came up in the last 15 years, 20 years. Actually, remote sensing and satellite imagery is one of the first disciplines that have archaeology and cultural that have applied this. So this goes back beginning of the 19th century, and we also have spy satellite sensors all over the world during the 60s and the 70s. So we talk about 60 and 70 years ago. So one of the main advantages of why using satellite technology to monitor cultural heritage sites and monuments is because actually it's the only way to go back in time and have an image over an area that probably now does not exist. So that is a lot of example of that. And how do we use this information? We use electromagnetic radiation. I'm not going into details, but just to give you an idea, we try to see things that we cannot see with our eyes. So we go beyond the visible part of the spectrum. We can see the near infrared part of the spectrum. We can see the middle infrared part of the spectrum, also the thermal. So we see other things that we cannot see as humans. So this is really crucial, and we try to elaborate this data with specific softwares and so on, and we try to combine all this with other geographical data that are coming either from GPR or from drones or from airborne and so on. And we have a lot of difficulties, so of course it's not so easy because you have to combine all these different data. It's not coming from one sensor, so it's easy to use. So the problem here is how you can get the maximum information using different sensors with different characteristics, different resolutions, and so on. And of course you have to, every time you have to choose the optimum solution for your specific case study. It's not always, what I'm saying to my students, it's not always really simple to get now a drone, because drone is in fashion. You cannot do a drone over the entire Cyprus. I mean, the cost is too expensive. So yes, you can use drone, capture images for specific spots, but if you want to capture a large extent, then you have to go to the satellite, or you have to go to airborne sensors. And there is a lot of literature there. I'm passing. So there is a lot of publication, and there is a lot of trends, increasing trend of publication here. Just to highlight this, here you can see the keywords based on Scopus engine. Probably you are familiar with the Scopus engine. Is one of the largest engines that you can find scientific articles. It's one of the most prestigious with Web of Science. So you can see how technology has been moved based from the scientific part, starting from the 3D documentation, image processing, and coming. Nowadays, the hot topic now is, as you can imagine, is AI and deep learning. So this is something that's currently in progress. So there's a lot of discussion on how we can use it. And I'm coming to the core of the presentation, which is actually what we do when we have time. We use geoinformatics and Earth observation either for site detection, I will try to explain in a while, or for heritage monitoring. What we talk about site detection, so our interest is to detect, is to identify buried archaeological remains. So sites, archaeological sites that have not been yet excavated. And there are a lot. Not every site have been excavated. There are hundreds of other archaeological sites that will be excavated in the futures to come, in the centuries actually to come. So there is a wealth archaeological context beneath our foot. And this is how we try to use, so we use some kind of interpretations and image processing and trying to identify these case studies. And here you can see a really nice example of even using high resolution, medium resolution satellite images. So you can see earthworks, Bronze Age earthworks in Romania. This is a case study. So you can identify the edges of how these earthworks are. So this can help archaeologists and conservators to target in specific sites. Just see the scale of what we are talking. So we talk about sites that extend up to 2 kilometers. So it's not easy to monitor a 2 by 2 kilometer square. Even if you know that there are archaeological sites there, it's extremely difficult to identify exactly where these sites are. And of course, you can do a lot of other research and to get optimum results, better results, to enhance things and so on. And the second part that we are interested of is about using satellite technology for risk management and hazards detecting the threats and so on. And we try to use open access data. There are satellites that are available for free, especially European ones. Probably you are familiar with the European Space Agency, ESA. This is a European flagship program, the Copernicus. So you can get every 3 days all over the world an image for free. You just do a login and you can download an image whatever place you want, so you can get that data. So we use this information and we try to do a lot of things as the one I will show you now. Let's say trying to detect urban sprawl, urbanization process. It's a slow process, but it takes time. But eventually you can see that if we go back, let's say 40 years ago, okay, we can see up to a 300% expansion of the urbanization. It's a slow process that humans don't really understand, but if you go back in time and try to map and document it, then you can see the threat of urbanization against cultural heritage sites. And here is a case study of Limassol, where we are here now. In the last 10 years, we have these sky towers, or you will see in Limassol nowadays. These were not, I think the first one started around 2015, something like that.
When we started here,
yeah.
they started also.
So you can see all these 1, 2, 3, 4, 7. You can see all these are changes in the signal of the radar sensor. And of course, these are the spots where the sky towers are found. So this gives an impression, and you can measure it, you can do. Another example, not good, but it was from scientific part, was really interesting because this was an active fire coming for 3 days, one of the largest in Cyprus, back in 2021, if I remember correct. So during the fire, when it was expanding, then the satellite sensor could monitor the extent of the fire, also measure the intensity of the fire, so you can use a geographical information system, you can place all the archaeological sites of interest. So this gives immediately information to the stakeholder, because it's a time that you cannot go there is a fire. So how do you know if something is going on, if something is happening? So this gives an idea. Such techniques are usually applied during and every.
This is another one area where our countries are working together, yeah? You know it very well. Each time when there is a forest fire in Israel, first arriving there are the citizens. And when there is, and the Greeks. If there is a fire in Cyprus, the other way around. That's, and we hope that we can establish also within the CREAMS framework and beyond a new cooperation, in this domain that we are presenting to you now. Sorry for it.
So we try to do other things as well. Now an example of earthquakes. So nowadays we can use satellite after an earthquake just to detect millimeter displacements, both in horizontal and vertical level. So this is something that cannot be captured with our senses, but you can monitor after an earthquake what has been displaced or not. So once you have this map, you can draw also overlay the sites of archaeological interest and try to do a stability map, if something is in danger or not. Another example, this is from the explosion in Beirut. I don't know if you remember that was back in 2020, if I remember correct. There was a huge explosion in the port of Beirut, and in the next few days, the UN has already announced that there were more than 16 historical buildings affected by this huge explosion. So this is something that you can do, trying to identify areas that have been affected. So these are usually called proxy maps. This is a first indicator before going into the site, trying to see where are the most affected area, because we talk about an extensive area, so you need to know where to start with. A different topic is we have used this for energy efficient, because in historical centers we have a lot of traditional buildings, so we try to estimate the surface temperature and try to get the performance, the trends, how temperature was, the numbers of temperature, let's say the temperature values for the last 10 years over specific buildings, both here in Limassol as well in Nicosia. Another interesting thing is we try to use also low altitude systems such as drones, to detect surface ceramics. Archaeologists do not go in blind trying to detect, they excavate, they do a pre-processing, they do some work before. One of the most important is the field campaigns. So they go into extensive field and they walk and they try to find small ceramics like this one, which are unique, and these, let's say, are Bronze Age and so on. But here we're trying to support them using drone technologies and also machine learning and AI algorithms to detect areas that they can focus. And we talk about an extensive area. This is more than 100 square kilometers. It's a very extensive area that cannot be done by foot. I would like to finish with this one. It's the example I was showing before with the displacements, earthquakes. Here you can see an example of the satellite, how it's orbiting around there and taking signals. We do a standard processing, as the one I will skip now. You see the accuracy that we get, it's 0.7 millimeter per year. So once you do this technology, you can get for each point, for each value, an accuracy of less than 1 millimeter per year. And so these are data that are free. You can go into the EGMS platform, just log in, and you can see. Here is the UNESCO World Heritage Site in Paphos, here in Cyprus. You can see how the displacement, both in horizontal as well as in vertical way. And here are some examples from, I will go. There's another example here is the Agios Neophytos Monastery.
Yes, the San Neophytos Monastery, the way I showed to you, the Cave of the Sun, which is under monitoring, and here is voila, it's moving. The entire mountain hill is moving. So the day will come when it's going to collapse, if there is no intervention from the Department of Antiquities.
So you can get the numbers of average displacements and so on, and you can do a further processing. So it gives you an idea of what is going on. You can go back in time and see, at least starting, these data are coming from since 2016. So you can go back 8 years ago and start trying to understand what is changing and what is moving in the area.
This is another one case study, and this is the worst case that we had in Cyprus. The government released automatically €1 million to save one of the oldest monasteries in Cyprus. Yeah, without this investment, it would have been a disaster. And here, voila, the proof.
And
yes.
Also in Timios Stavros.
Yes, another one example of a UNESCO World Heritage Site too, yeah?
Each point has a different profile, so this is the important. So this might not be moving, but this point might be moving because there is a landslide or because there is something else. And So these are really important. They're products that are delivered by using satellite technology. So how you can use this? You can bring in people coming from civil engineering, so they can do a finite element modeling, structural assessment, and so on. And this is what we're trying to do in a project that we're running, and trying to blend both the satellite and the ground sensors with civil engineering and simulation.
It's a multidisciplinary approach. The digitization is not just keep your phone and then scan. No way. Yes.
So that's it for my part. Just to a conclusion, what we see in the last years. I mean, there is a lot of technology, and most of our data are free and really to use. Also, we talk about open access software and open access data, but there is a gap of how we transfer this knowledge to the local stakeholders. So this is how we try to educate the new generation as well, but also we try to bridge this gap, because we see the opportunities of how you can use these tremendous technologies that are there for really interesting topics such as the cultural heritage and
multidisciplinary, holistic approach for the digitization of the past, especially for virtual exhibitions. That's a must. Yes.
Yeah, that's it. Yeah, we'll have a lot of all these geomatics technologies that are coming in the next few months, and also climate change is another thing that we try to see how we can support the stakeholders, and that's it.
Yeah.
Sorry if I
No,
confused
it's
something.
okay. It's okay. Thank you very, very much, Athos. Anything to ask Athos? If there is something, okay. That's from the space down to the ground, yeah? If in the case we want to create a virtual exhibition of monuments or sites, it has to be the space, observation. Otherwise, it's something wrong. Okay, that's it. And there is another one part which is extremely important for CREAMS, and we fly through that presentation. Petros, that's metadata. You heard the metadata that has been covered yesterday by Marius around the slides 25 to 32, yeah, in his presentation. And now you will see the metadata which is used by whom? By the stakeholders, by the owners of the object, by those who give to the artists access to digitize. This is what they are requesting from you, and if they request it, the owners, the stakeholders are requesting that, then it's a big issue. If it's not the case later. But
good morning, everyone, and welcome in our university and Limassol. My name is Petros Artemi. I am a librarian and system administrator of our repository, and I will present you APSIDA project. Is our repository that we store all the documents, all the data that produce by the digitization methods.
so, Petros, sorry for interrupting. If, in the case we digitize, where do we preserve, you as artists, the content within the CREAMS project? First, where? Just in an archive on the cloud, and that's it. Where? It has to be a place. On our side, there is a repository. On our side in Cyprus, at the Cyprus University of Technology. In Europe, there is a library, the Digital Library of Europe of Cultural Heritage, which is the biggest, the largest in the world, and that's European. Yeah? So, and we are working as UNESCO chair with the Library of Cyprus. We don't want to do the job alone. That's their responsibility. That's also their professionals for that, and this is what they do. And there is where we host all of our content. And whatever we're going to digitize, replica or not replica for our project. There is where we are going to be, and from there, are going up to the CREAMS cloud space. Okay? Well, now.
So, I will present you at the first part what is digital repository, about the APSIDA project and the documentation method. And the second part, we see some examples for our repository. So let's begin about what is digital repository. We define a repository as an online information system that stores, manage, and preserve digital content. The content on digital collections are digital objects. For every individual object, we give a unique ID. And overall, digital repositories are an essential part for the preservation, accessibility, and dissemination of digital content, ensuring that all this information produced by digitalization is available to the current and the future generations. A bit history about repositories. The first repository launched in 1991 by Los Alamos National Laboratory and contained preprints in physics. And closely they produced a new repository in CERN Research Center that contained a preprint and scanned series of physics reports. And a pivot step in the repository was the open access initiative that encouraged the creation of repositories to freely share and research output. So digital repositories are closely linked with open access movement. And the main idea behind repositories is to establish a global network of repository that different international aggregators harvest all these material for repositories and make this openly available and accessible to everyone. So through repositories promotes the transparency and reuse of the data and collaboration in research. And digital repositories are used across various domains, mainly operated by universities and research institutions and government organizations as well. There are different types of repositories and distinguished by the type of the content they host. The most common type of repositories are institutional repositories and cultural heritage repositories. Institutional repositories mainly manage the university scholarly publications and theses or conference presentations and conference proceedings. So they showcase the research output of the university. Subject repositories focus on a specific discipline or subject areas, and cultural heritage repositories managed by museums, libraries, and cultural institutions. And another important repositories is aggregators like Europeana, OpenAir, that they harvest the material of the repositories and is under a central location. In our university maintain 4 repositories, 3 dedicate to cultural heritage content, and 1 is the institutional repository named Thesis that contain the scholarly publication of the university. And In the next slide, I will present you the Apsida, that is a digital repository for cultural heritage content. Apsida developed in 2012 and is the result of a collaboration between the library of the university and the Digital Heritage Research Laboratory. Apsida is contain a wide variety of historical content. It includes more than 27,000 digitized documents, such as photographs, sculptures, 3D objects, stamps, and videos, and etc. The mission of the project is the preservation and dissemination of cultural heritage and the showcase the history of Cyprus worldwide. We'll see some Apsida features. The storage. Apsida provides a secure place to store digital files that are produced by digitalization, ensuring that content is preserved over the time. The management of the material, the content of the repository can organized in different collections. We give subject keywords, tags, and also provide some different access rights and different workflows for the submission of the materials. And furthermore, we can create user accounts with different rights, like administrator, moderators, and research that can self-archive the material. Search and discoverability through metadata and indexing, all the material is easier to discover and access digital content. Interoperability also is another important feature, that our repository is compatible with the international protocol OIE, Open Access Initiative, protocol for metadata harvesting. That this assures that the content can be shared and accessed across different platforms and different institutions, which is vital for collaborative research and global information sharing. And the preservation, that preserve the digital content for long term, ensuring that digital content remain accessible over the time. Here is an example of the workflow process that contribute content to Europeana. The first step is the submission of the material in our institution that is organized in different collections with the documentations. And the next step, through the OIE protocol, we provide the material to Europeana. We can provide through the the Cyprus National Aggregator, or some local aggregator of European projects. So the next slide is about the documentation. Documentation is a crucial part for the discovery, the preservation and sharing of digital items. Through documentation can provide detailed information about the life, about the history behind the monument or the historical site or a monument. For the documentation of the material, we are using the Duplicon. Duplicon is widely used metadata standard for describing research in digital repositories. The schema of Duplicon consists of 50 metadata elements for describing a wide range of resource as photographs, videos, documents, 3D options. So metadata is a data that provides information about other data. And here is an example of a metadata. It's a record of a sculpture of the current digitization project of the museum in Sweden. And here the different fields, the different elements that we describe through the duplicate is the title. We give the name to the resource, the creator. Usually the creator is the person or the organization that is responsible for the creation of the resource. The subject is the topic of the document. We can give some keywords or phrases that describe the topic or the content of the document. The description is a textual description of the resource, provides additional information beyond the title. In the description we can provide more details as information about the people that captured in the photo, the locations, the dates, and the history behind the resource. The publisher is the entity that is responsible for making the resource available. It can be an individual, organization, or entity. The contributor is the people or organizations who contribute to the resource. The date is associated with the creation or availability of the resource, and it can be a significant a single date or a range of dates. And we give details about the type. For example, it could be an image or a video or a data set. The format, the file format, or a physical medium of the resource. For example, would be MP3, JPEG, JSON formats. For every item, we give a unique identifier that is a reference for the resource. And the source is the original resource from which the present resource is derived. We provide the language of the resource, the relationship of the resource to the other resource, the coverage is the spatial or the temporal coverage of the resource, and the rights. The rights is the information about the rights and the access condition of the resource. Mainly we use the Creative Commons license that are a set of a standard copyright license that allow creators to grant specific permissions for the use and distribution of the creative works. And some future plans about our repository is the citizen science, to bring citizens to contribute content into digital repository. Already we have some collaboration with some municipal to contribute to the documentation of the material. Using the citizen science is a collaborative approach to scientific research that involves the general public in the documentation of the data. The next plans is to synchronize our repository with a GIS system, so all the data they synchronize in automatically way. And the last plan is to implement standards and practice to display different formats of 3D models. So the repository would be compatible to expose the different 3D models. So this is the presentation, if you have any questions. And the next part, we'll see some examples for our repository. Here is the website of APSIDA, Digital Repository.
Maybe we need to share.
It's okay now, can you see the lines? Okay, for the menu we can see and search the different items. Here is the different collections. And the last project with related with Mnemosine project.
You choose some of the museum objects that we brought from Sweden. That will be nice. Because those objects I would like to see in the virtual exhibition of CREAMS. That's going to be wow.
Okay, this is a record for the last digitalization process for the museum in Sweden. We can see the title.
But pay attention, this title is good. You see there a reference, V.051, you know what it is? That's the reference in the repository system of the Swedish Department of Antiquity. And at the same time, a reference to our Department of Antiquity. You see automatically the object is linked to the original repositories, to their owners. Okay? It's extremely important. Why? Not only if a researcher wants to further search to find any other information, but also for the search engines. Yeah? Someone wants to search, find something, then automatically knows where the object is coming from. A short description, the creator, and the creator is not us, unfortunately, not even the Department of Antiquities in Cyprus. You see there is the museum in Sweden. That's now something to send out as a message to the visitor. Yeah? Source, of course, again, is from the research results of the Swedish authorities. Yeah?
Yes, and also I would like to mention that in this case, the museum, they make the items publicly available, accessible from everyone, and this is a good case to share all the history behind. Is not only the museum, but it's accessible worldwide.
Open access. full open access. Or the way of how we say, ladies and gentlemen, it's extremely important, yeah? Gold open access. Gold open access, it means no rights except one. That if in the case you use the content, you are obliged to do what? To say who is the owner, to make a reference to the source, yeah? To the Swedish authorities, to the Cypriot authorities, to us, and so on. That's it. But you can take it, you can exhibit it, you can take it, you can print it, you can do whatever you want. Okay? Free of charge.
So the rights remain to the museum,
This
but
is
they provide access to everyone to share and reuse. And you mentioned the Creative Commons license. Okay, this was the presentation and
then the location,
the
the location,
documentation.
if you go down to the location, please. Location. Location, you see? Those are the, no. Go up. There, location. You see the location? Those coordinates are from the world map. Huh? So if you take them, enter them in Google, you know what's happening? You will land automatically at the museum in Sweden. Yep. So, sorry. And then the materials, extremely important. Huh? The measurements. Yeah, all this is the definition of metadata. And this is what it has to be, in place for the description of a 3D object in our repository. This is our opinion. Otherwise, there is a problem. And then, of course, this, whatever it has to be visualized, or in our repository, in the CREAMS repository, it needs to be accompanied not only with the 3D, but also with a set of images. Okay? Yes, sorry.
it's okay. I finished the presentation. If you have any questions.
Yes, thank you very, very much. But this is a nice inside presentation of this, what it is in place here at the university, where we work directly with the stakeholders for the benefit of the community. And in our community, the first place is coming from the university, from our students, from people like you. Okay? Researchers, then the owners, the stakeholders, and so on and so on. So if you want, so far as metadata, I am sure that Petros mentioned that, there are two standards in metadata. Please write it down. ISO certified standards. The one is LIDO, L-I-D-O. This is the standard of metadata used for museums. Museum object, LIDO, L-I-D-O. And then the second one is the Dublin like the city, Dublin Core, C-O-R-E, metadata scheme. Why Dublin Core and not to have one? Why do we have two? Because the Dublin Core is used for the librarians, pay attention, librarians, the Lido for the museums. Okay? If you download the two documents, and there are two in the documents, you will find two templates. You just take the two templates, put them together, 2 pages, and then you compare the fields, then you will see automatically the differences, and you will get automatically the message why they have two different. So, thank you very much, but please. Yes.
One question. Here in
Louder so that the
university, the Council University, you have your own server, or you link to in the
yes,
national server?
we have our own server. You will not believe it. That was the first ever server at the university, and it's directly under our laboratory, under the UNESCO chair host place room. and it's that in the data center of the university, well secured and so on. And we have even a dedicated line from an internet provider to go out in case that the line of the university comes down. Our content, because there is a precondition of open access to the entire content, to the work that we are doing, is hosted also by Europeana. It's harvested in Europeana and available via the Europeana. So if someone now wants to create a virtual exhibition, now I'm coming to you, because you are the first users, you are the first people to test the CREAMS infrastructure. You don't have the infrastructure, let's say, the equipment to digitize, but you have the content available, let's say, in Europeana. And you because there, whatever is there is certified. Not only the content, the tangible, but also the intangible, the metadata. You go there, you download, you take it, you use and reuse it, automatically. And so far as the metadata CREAMS structure concerned, you are sure it's okay. The 3D or the 2D or whatever you have there is also okay, it's certified content. Yeah? Certified, I mean high quality of data. It's an exception to find there something which is not correct, which is not correct. And if then, so you are obliged to contact the owner or the provider so that there is an improvement, direct improvement. So that's a very, very, very important issue, and I wanted to highlight that, yeah? Thank you very much, Petros.
So, my name is Rebecca Fatal from Israel, from Shankar. We are responsible in the CREAMS project for Intellectual Output 5. We are responsible for creating educational webinars for this project. I'm not going to get into the webinars that we did because we update the partners monthly about the activities that we do. But within our position in the project, we try to use the platform and work closely with Cognitive UX and Mario's Belt's team to give feedback on the platform and try to improve it. We have used the CREAMS platform within several curation courses in Shankar for the past year. And now, this past week, we have organized an intense workshop that deals with curation and virtual reality design exhibitions. I'm going to show you a little bit about the activity that we did. So, the course, I'm the main lecturer of this course, but my co-lecturer is Galit Gaon, which is a curator in our university, and it's geared towards fourth-year students. This is the participants here in this course, which take some specialization in curatorial studies. And what we did is we started off with talking about curation in general and what it means to curate an exhibit, what's the thinking behind this, and what changes between the physical gallery and the virtual gallery. What happens in this transition from physical space to virtual space? We went through the process of collecting material. The assignment that the students got is to create a virtual gallery of their own design portfolio. In these galleries, the students display their work. It's per se a three-dimensional portfolio that shows each and every one student's work. So each student brought their own material from their own projects and created their own concept that they want to show within this gallery. So for each student, you will see that the concepts are very different and the projects vary a lot as well. On the second day, Cheval Nir, who is also a team member in the CREAMS project, came into the workshop. He taught the participants the platform. This training activity took like around 3 hours, and then the students actually started using the platform, starting from building their own gallery once they knew their concept and what they wanted to do. And then we had 2 more days of intense working within these platforms. We had the support of your cognitive UX, which heard a lot from us over the past 3 days with all kind of bugs and issues that we had. And thank you for the support. I know we drove you crazy there. But we had some quite impressive results for applications for this platform, which you're going to see in a second. I'm going to just have a little teaser here on what we are about to see about our workshop, and then we are going to go and see each individual gallery presented by the students. I cannot give you the sound, but there is some background music. But this is a workshop in Israel while we were working within the galleries, and then we presented the galleries in front of a panel of lecturers that are in the field of interactive architecture and curation. And there are some attempts in the Oculus that we try to get into our spaces. We see in this version of the CREAMS platform the added ability of having 3-dimensional objects uploaded in the space. And we used this ability also to add partition walls and create a more complex gallery than the modular gallery allows. Concepts behind each gallery. They will also talk about where the platform actually served their purposes and where they found challenges, which was very good feedback for us as a team to understand where we are standing with the platform and what improvements need to be made.
Hello. Can everybody on the Zoom hear me as well? Okay. Good. Hi, I'm Jordan. I'm from Shankar. I finished my 3rd year in interior design, as all of my colleagues have as well. In our studies, other than just looking, observing and researching and designing space. We also focus on the experience in a space, which is why we also learned a little bit about curation and exhibition design. And this is what we try to imply on the CREAMS platform. So each one of us focused on our own portfolio to use as a case study, I guess, on the platform. So we each developed our own concept according to her own portfolio and what each student wants to exhibit and show. And we'll tell you now one by one what each of us did on the platform according to her own idea. Okay, can everybody see the space? Okay. So this is my exhibition. Welcome to my portfolio. What I did was focus on three fields that I work in. One, analog photography. The second, DIY projects, which is do-it-yourself. Taking objects and improving them, maybe objects that otherwise we might throw away, and just giving them new life. And the third subject that I am presenting is in what I'm actually presently studying, which is interior design and space design. So I'll start by saying that using the platform was a really exciting and unique opportunity to be able to see artwork exhibited in large size and format without any physical or financial limitations. It's really an experience as an analog photographer to be able to see my photographs live, printed, experience a space with them exhibited. And I didn't have to print anything or have to do with any technical problems or light reflecting in a real gallery. And it was really an amazing experience to see. This would be my analog work. This, as I said, is the DIY project. The navigation here is a little slow. Sorry for... What you can see here is that with the platform, I was able to manipulate photos, for example, not only to be exhibited on the wall, but also to change their angle within the platform and to have them on the floor or in other places in the exhibition. You'll see that they are on a podium. You can play around with the angles of photos, and it was really interesting to see what you can do with that. I will say that there was a challenge within using the photos that I think I would appreciate. For example, I used some photos and glued them up on a full wall. If there was maybe some kind of option to take a photo and set it as a wallpaper on the wall instead of manually adjusting it, because it takes quite a while. Maybe being able to crop images within the platform according to sizes of the wall. Or maybe after I uploaded it, I saw that the format of the photo wasn't exact, and if I would just be able to change that within the platform, it would be really much easier than doing it outside and then having to change everything while uploading it to the platform. And also the rotation of images does almost everything except from clockwise and counterclockwise on the wall itself. So these were a few challenges that I wanted to bring up. Other than two, sorry, I'm struggling with the navigation a minute. I'll do it a little slowly. Okay. Other than prints and 2D images, לשים כאילו לא עובדים. אז זה ב-WS, זה גם אמור להיות. זה עבד. Okay, so here's where you would enter the space design and interior design. It was really fun to actually play around with what options I had to build the space itself. It works in modules of 5 by 5 meter, 5 by 5 by 5 meter cubes that you can put together or deconstruct and create a space like that. So you can really play around with it a lot, and I think it's a clever module. Although I will say that there is a little bit of a limitation that you can't exceed a number of cubes, so if you want a really big gallery with a few more complicated shapes, maybe missing a few cubes in the middle or something like that, it wouldn't support the structure. But using the limitations, I think that I reached quite an interesting structure. And also, this is how it would look like to have 3D objects, large 3D objects in the space, which I think is also a great opportunity. This was a project that I worked on last year, and we built a pavilion, and because of safety reasons, they wouldn't allow us to build the object from wood and the material we actually wanted to build it from. So there were all kinds of limitations that we had to deal with, which on the platform I didn't. I could choose whatever material I wanted it to make it from, and it worked out really nice. I will add though that I couldn't edit the texture itself, which means that it's the photo of the wood projected on the object. I just had to use it as it was, and otherwise it would be nice, like in our 3D programs, to be able to scale the image itself, maybe change the angle on it a little bit so that the feel of the material that I used could be more under my control. I think that would be the last thing that I want to talk about, and to also give like a lot of compliments to the programmers, because it was amazing to see how the end of one day we gave like a list of a few things that we would like to have fixed or improved, and the next day it was working. It was very responsive, very quick, and really nice to work with. So thank you very much for the opportunity, and I'll let my next colleagues present their projects, and enjoy.
My name is Eden. In my portfolio gallery, I decided to choose 4 different projects that basically showcase the different skills that I have gained over the years. So my gallery is divided into 4 spaces, giving each project a lot of space to go through the whole process of the project and really show what my skills are. Designing the space and learning about galleries and curating and designing galleries, we learned a lot about liminal space and how important it is to have that space in between galleries, letting the viewers kind of walk through and have a think about what they saw, what they're going to see, so they have like a good introduction to each gallery. So that was something that I really wanted to focus on. So as you can see in my gallery, so before each space, you were kind of introduced to the next project. You have kind of the name of the project and a little bit of information about it. And then as you walk through, you can see the whole process. I really wanted to kind of have control over the viewers, like what they see, to really guide them through it. I didn't want it to be kind of a gallery that you can just walk through and see a lot of different things. I wanted to really guide them through how I want them to see my projects. So this was one area, and then again you kind of meet this liminal space, that you have a little bit of a clear area where you can be introduced to the next project. So I'm actually going to talk only about one main challenge that I had, which was the 5x5 model. It was very, very convenient for me to use to kind of create the whole space. But the challenge was that because it's 5 meters, so it's actually very big, and it didn't really allow me to create those little nooks that I'm looking for the liminal space. But the good thing is that actually with the new update of uploading 3D objects, it allowed me to create these little dividers as a 3D object, upload it, and then use it as like a continuation for the wall, as a divider. So that's basically these wooden pieces that you can see. I do think there's still a lot of things we can improve, if it's maybe seeing how we can connect the materiality of like those 3D objects also with the walls that are given, if I would want to have a wall that's like more continuous, and working on that. But I do think that also space-wise it allows a lot more than just like uploading a 3D object. It opens up a lot of opportunities. I would like to say regarding the whole conversation we had yesterday about authenticity and everything, that I think for us in our field, we experienced that the virtual world allows you to enhance a lot of things and maybe showcase them differently than what they are in real life. I think maybe for artists and for designers, it's also like a very interesting thing that we can do with this platform. So this was the main thing, and we're getting into the last space. Thank you.
Hi everybody, my name is Karen, and the concept of my gallery is to show the observer my narrative design and my point of view. So the first wall is showing you the jumping off point is showing my portfolio, my principles as a designer and a human being. And as we go to the left, it shows you how my space is divided. So in unusual way, I decided to divide my space, and it starts with L, like refers to large. And I start with the large scale and it goes down to S, a small scale. And as we go, you can see that here this is large scale that refers to environment mapping, architecture, like a general view of what is going around us, and also all the way you can see that I use a lot of amount of light, like a lot of layers of light. So here I would like to say that it would be very nice to have like a multiple shapes of light, like a linear light, or like something more than like a circular, so we can, like as a designer, it's like very important for us and our main goal to have a very good lighting and to create like a dramatic ambience, but I think I succeeded to do it with the platform. So here mainly you can see the two-dimensional way that I wanted to present the architectural section. Like I did some few niches, also make like dramatic, like very like solitude point when you can observe and get impressed from all the projects. And this is like a hint of what's coming next. It's the interior design project. This is like a big image that I put on the wall. It gives like a feel. It's a continuous space, like a next door space.
Of perspective.
Yeah, it's like another perspective, like you're going into another space. I think it's like in a very good quality. I can say that it's a successful image. And this is the next section. I used here with three-dimensional. The light did a good job for my objects. Let's see what next. So this is the interior design and the space design section. With the ability to enlarge the scale of the objects, I could take a small object and made it as a sitting object, and that was a very nice option. And also, it would be very nice to have the option to control the walls like as an individual, not like a stack of walls. So we could put materials or control the colors. And as we go to the next section, the small section that talks about like functional, small details. This is a video. Let's see if it works. The video doesn't work, so continue. So I created like a circular space that leads you to the start. Like as we finish here, you can see that we start again with we go to the start point. And that's it. Thank you.
Okay, so hi everyone, my name is Noah. I am a third year student in the interior design department in Shankar, Israel, and welcome to my portfolio gallery. The theme here is scale. My gallery has a long hallway with 7 sections. It was easy to do that due to the flexibility of the platform. I was able to arrange the space the way I wanted to. So I will start here in this mandala. It was created in a 3D platform in Grasshopper, which is a Rhino plugin. And the first section is not to scale. It has a video from a protest exhibition I did last year. I'll try to play it maybe. You can see a quick video of the exhibition I did.
Mario, in some galleries, the video, like you see, we were able to play them. In some, it didn't work. We couldn't find a pattern when it doesn't, where it doesn't.
There's a few sketches I did on my iPad. I wanted to show in each section different mediums and different scale of my project. This is the 1 to 200 scale. You can see the labels on the floor. It looks really cool in the VR goggles. Here you can see a few models in 3D laser cutting and a few CAD drawings. Here's the 1 to 100 scale. Another challenge I faced was changing the color of the gallery's walls. When I tried to do it, the gallery crashed and I had to start over and I placed the image manually on each wall I wanted to change. It was a little time consuming. This is the 1 to 50 section. It combines the model with 3D printed and laser cutting. This is the 1 to 20 section. The 1 to 10 section highlights a 3D printed model here on the front wall. And finally we get to the pavilion at the end of the hallway, which inspired the whole theme of the gallery. I created it in mixed media. It's 1-to-1 pavilion that I did last year. The shape was created in Grasshopper and it has connectors in 3D printed from PETG. Here you can see more explanation about the pavilion. And it was really cool that I could place it like right in the gallery. There's another video of the process, doesn't work. And the 1-to-1 section includes also oil paintings. I I did in my first year, and another 3D parametric object. And you can walk through the pavilion. And make yourself the way to the exit. And that's it.
Thank you, Mom.
No?
Is your
Okay, I'm here. Do you hear me now?
Yes.
Okay. Hi everyone, nice to meet you. My name is Linoy. I'm also a student I finished my third year in Chicago as well. This is my portfolio, the gallery of my portfolio. The concept of the gallery is a presentation of all the different types of artworks and different types of art from all the from projects that I did on those 3 years, like architecture, interior design, photography, visual communication, and 3D modeling and laser cutting. The space built as one big open space because I wanted to let the visitors to choose which project they want to see first, which wall they want to go there first, so they can choose it by what attracts them the most from like the first sight. I put here on the beginning a big photo of one of the projects that I did. The illustration makes you feel like you are part of the project and part of the space, and it feels like it makes you go inside and actually be a part of it, and it makes the visitor a different experience of a gallery that they didn't get to get in other places usually. So this is the first part. Here is the 3D modeling. It uses as a pavilion, and you can go inside and go around it. And it also makes you get a different experience of what you usually used to. A little challenge that I have with 3D modeling is that originally the material is wood of the model, and I didn't access to put the material in the platform. It uploaded just the model without the material, and it got just white colored without the material on it. Another challenge that I would like to share is that some of the pictures and the video, for example this one, is stretched out or rotated than they originally are, and I couldn't rotate it on the platform, so it uploaded differently. But here you can see the model in laser cutting and the process of it. But other than these two challenges, it was a really great platform and really
really easy to understand and to use it, and it was really nice to see with the goggles, to see it actually like for real, everything we did and all the process that we did, and it was really nice and really impressive to see it for real. That's it. Thank you.
Thank you.
Despite that my project talks about if I'm more technical person or more creative one, like, and the tension between them. And I noticed that in all my projects, they talk about the technical things, like in architecture or art or something like that, and how my creativity comes in the project. This is one of the projects that I've done this year about one of the kibbutzim in Israel that they went through the 7th of October. And we took their history and made some real project for them to see how they can see in a new version of their kibbutz. And the other side is more surrealistic kibbutz that takes the kibbutz to different ways. So you see here in one project 2 options to see the same place. One of my challenges was to understand the space and how the scale of the space is, because this is all our field about. The cubes are 5 on 5, but it's really hard to understand the scale because you don't feel that this cube is 5 on 5 in the computer, so you cannot put some things or objects and understand how it will be on the wall. The second thing that I was challenged is that my plan for the space was the entrance will be in the center, and I could put all my objects and all my art and projects in the other spaces, but in the middle I couldn't, and every act that I did, it crashed. And maybe because all the spaces are with a lot of material and the space and the project is very heavy, or it's like difficult for the platform to understand like the entrance in the middle and there's another space in the other side. So every time that I try to put something in this wall, so it's like in a couple of minutes I haven't seen it, it's like a hole in my project.
Yes, so this is an interesting discovery. I think that maybe our module system doesn't support centralized spaces when the starting point is in the center. I suspect that maybe that's why she had so many issues and these central walls, whenever she was putting something on them, it was crashing completely. So this is something maybe to look into.
Yeah, I was like working about 5 hours, like again and again, like it crashed and come back, it crashed, and I tried just to put some labels and text, and it was really hard and stressful. And
a center like in a rhino?
No, if you know the platform, you can build your own gallery, and the first module that you build the gallery by 5 by 5 by 5 spaces, cubes. And cubes that are next to each other, the wall is eliminated automatically, so it becomes a longer. So what Jana wanted, her concept was a centralized gallery that goes out into 4 different sub-galleries. So her starting module was in the center of the space, and we think that this is what kept crashing her projects, that maybe our module system is not supporting in the platform a centralized gallery like that. All the other galleries had a starting point and an end point, and it worked fine. So this was some new discovery with her project about the platform.
And now I'm showing you like I think my most technical project, interior project, that we worked really with plans and sections, but we really try to put our creative view, like to show images in different scales, to feel like it's really technical, but to see like people are making it, it's not like a computer or something. The third challenge that I wanted to say is about scaling 3D models. We even try to understand why it happens. Like if you put an element that unifies one element, like a chair, so the scale for on the axis works okay. But if I put like a chair and a table, so it works on. I try to show you. So that's just like in the X field, it's not working. Like this, it scales from X and Y, but in Z, it stays in the same way, and it's really looks weird. And I finished with like my art gallery, and I saw it's like a really good platform to understand, like to plan a space, to really see it, and like really, as Jordan said, not printing and trying something different, but if really work on the scale, understanding maybe we can like have dimensions that so we can really use it in the real life and not only in digital. And thank you.
Thank you very much. So one more student, she had some delays with her flight this morning and probably will be arriving later. But we have an additional portfolio, a successful gallery, a successful work. We can see the use of texturing and images to texture walls and even give the feeling of a concrete wall in the entry with the curatorial text. And there are different areas in her gallery that represent the different projects. She has a three-dimensional partition wall that is parametrically designed, explanation of several projects. Here we see a more theoretical project, which is about people that have lost a limb, and she has created a website that supports and connects the people with activities and with other people in their community. And I think this is, oops, there is no collision detection, so we've been navigating carefully in the galleries. But here we can see, I think this is a very interesting view that shows the three-dimensional object, the partition wall, and the image of this partition wall inside the space. It creates an illusion of continuation, so you can do interesting things in these galleries. So with that, I want to conclude. So I want to conclude regarding this workshop that we did. I mean, what you heard here is a little bit the challenges and the possibilities of the platform on real-life projects. You saw that the projects had a high level of complexity, so I know that we really challenged our development team, and we brought the platform to the edges, to the limits of its capabilities right now. Some things worked out, like you saw the galleries today inside on the computer, but we didn't manage to navigate within these galleries in the Oculus because of all kinds of technical issues. Some of the issues are solvable and some issues might not be solvable. But we are conclusion of the CREAMS project. I was talking with Marinos about this now in a corridor conversation in a few months. In February, this project is concluding. And I think that we should start thinking about what after CREAMS is concluded. How can we take this as a learning experience and continue working? And when we presented these galleries in front of a panel of professors in Shankar that deal with interactive architecture, interactive galleries, and curation of physical and virtual spaces, the question that came up is, we find ourselves in the metaverse. And when we are in the metaverse, do we need to adhere to the rules of physical space? The galleries that we have created in CREAMS, they still adhere to the rules of physical space. And the first thing somebody wants to do when they're in virtual space is to actually not comply with these rules. And I looked a little bit online about galleries that start playing with these limits of what's allowed in virtual space and what's not allowed in physical space, and what are the additional experiences that we can do. This is another example here, when we can see that the navigation is different, how we move around space, how we float around space is different in the virtual space. So I think as a team in this CREAMS project, we should ask this question and ask what it says about complying with gravity, complying with materiality, complying with navigation, the way we navigate in the physical space, how we move in the physical space. Does the movement need to be the same movement in virtual space? And how we connect with other users. So I think these virtual experiences, and we can experience art very differently. We have here the possibility to create something that experiences something that's otherwise impractical or impossible in the real world. It's an opportunity to escape, to create an experience of catharsis, of progression, of achievement, and you don't take any risk because everything is virtual, it's in your goggles. So you don't have to take risk in physical space. So I would like to encourage the partners within this project to think of how we can create or orchestrate new experiences in the metaverse when it comes to art exhibition, to use concepts like gamification and high-risk exploration and social engagement, and to try to create a new project, possibly a horizon project that has a higher budget that will allow development of something much more robust and something that's more cutting edge, and to use the CREAMS as a learning experience for us as a team. I think we are much smarter and knowledgeable as a team than we were 3 years ago, 2.5 years ago, and we can base our next proposal on this knowledge that we have gained from this Erasmus project for something that is richer and can enrich and actually improve the field of virtual experiences when it comes to art and art curation. So thank you very much for taking a look at the work that we did. It was an intensive few days for us to produce these galleries, and thank you for all the support that we got from you, Marius, and your team from Competitive UX. And Marino, thank you for having us here and allowing us, giving us the podium to present the work of our students and what they managed to do within our platform.
Thank you very much, Rebecca. Congratulations to you and to your students. Well done, very good.
If I may as well say,
Excellent also.
I'm impressed.
Development.
Nice work, and I'm very happy. Sorry to interrupt.
No, please go ahead.
In my head, just want to say that we are very happy as a development team to see what we have built being used by actual users who seem to be really engaged in this, and it's really nice to see it working, see tangible results, and the work is amazing. I'm very impressed. Congratulations to the students, to the Shekar team, to Rebecca. Very nice. Thank you.
There is something which I wanted to discuss with you. Pambos, okay, his English is not so good. So therefore I take the opportunity to send out the message to discuss. Following your presentations, Rebecca, you and your students, came to the following thoughts. He is the chairman of an association in Cyprus, the Professional Photographers Association. And it's the second time now that we bring up this point. First time was in February at the meeting in Cyprus. Is that they go to different events. They make what? Photos, copy of that moment in a digital form. Could be that it's a special ceremony of the family. It's a special ceremony when the child, first birthday. Afterwards, when the child was baptized, when he went to the school. That's time machine of one person. Now, the idea here was to create, at the end of the day, after a couple of years, a virtual exhibition. The evolution of the person over the time, in different occasions. Or, now that's the first one option. The second is not going also to family events, it's going also to village events, to community events, to festivals, to other traditional events. And instead of an exhibition of images, an exhibition of video clips. And because we are in Limassol is the capital of culture of Cyprus. For example, we have here every year the wine festival. We have here every year the carnival. And it's unique. We have here, now I don't know, the Saragosti. Signoberti is a special Cypriot word. It's 40 days before Easter. Yeah? 40 days before Easter. It's a big celebration in the city. All the businesses are closed, all the people are on the streets and are celebrating. And the day after, fasting starts. Okay? So, he and his association have a very big gallery of these, not only photos, video clips. And they want to exhibit, use the platform to do that. He is asking how. He was also surprised of this, what he saw here. Yeah?
Why not? Can use it for free. He can register, create an account as an artist.
So, Bambos, here is a challenge.
Every time we have an artist
we are recording, yeah?
Very good.
Excellent. Everybody is here.
Sorry.
Everybody is here, and we can follow you. Everybody can hear you. Everybody can see your presentation. Yes or no? Yes, of course. Of course.
Yeah, okay, very good. And Ayubina is around?
Yes, yes.
Very good.
Okay.
Do you have also the permission to share your screen if you need?
No, we cannot share multiple screens at the same time, one after the other, because we are recording, you know.
It's fine, I'm not really in need of sharing the screen.
Okay.
I can just talk quickly when you want.
Okay, great.
Excellent.
So my name is Sanet Bush. I'm here together with Ayubila Babu. We're sitting here up north in Trondheim. It's not so hot. So we we are partners from an art academy. And I have to say, after listening through your presentations and also after engaging with our partners for the last 2 years, we always face that things are a bit different at our side, and we're never sure if is it because we just don't get it, is it because we have so different students, is it because we are an art academy? So I think there's something interesting maybe also to address. It was quite impressive to see what you did out of Schenker and the students making very, very convincing exhibitions using the platform. So we were struggling with also different, let's say, strong sentiment from art students actually refusing such tools. So what we want to do in the next 20 minutes is we made a short workshop last week, and Ayu will talk a little bit about it, also about the feedback and what we did and what difficulties we faced. And then I wanted to make a short presentation about a digital tool we are actually using for teaching, and especially in collaboration with the students. So that's called Research Catalog. And the Research Catalog sits also in a larger context, and it's maybe interesting to see what it does and what it can't do. And there's maybe something to learn from. So this is why we wanted to share this in like a comparison, or in, just to look at something we are using and with what we are struggling. So, but maybe I can shortly input, if that's okay.
Okay.
And then I can hand over, or I can come back.
Yeah. Hello everyone. My name is Ayubila Babu. I'm with NTNU at the Art Academy here in London. I'm just going to run through some thoughts from us engaging with students with the CREAMS platform last week. And this is an open and ongoing conversation that we're having internally here. Apart from, we have 5 students for this session now. We ran for about 3 hours with them. Apart from regular observations that we pass on to the team, we'll feed into maybe teacher requests or fixing requests such as issues with moving through walls and
Ayodel, sorry for interrupting. Sorry for interrupting. Here is Marinos talking from Cyprus. Your presentation is not moving. We see just only the first slide.
Okay, I'm not using the slides at all.
Ah, okay.
Unless we use the slides.
So, okay, you use your personal notes. Okay, we didn't know. Okay, thank you.
Okay. Yeah. So apart from issues like that, moving through walls or the desire to be able to delete accounts, part of what I found interesting was an observation that the grid-like way of creating the exhibition room was found to be quite intuitive. Quite a number of the students were in favor of that. They liked it, that it was so easy to just create an exhibition space. But at the same time, they keep quite strong against the inability to compromise the space in any way that they wanted. So they like the simplicity of just keeping boxes and creating rooms, but they really protest the inability to customize it, which I think the presentation of Senka that we just saw has shown to an extent how that can be gated by the ability to bring in 3D objects into space, which we were not aware of the thresholds of the things that very easy to relocate. So that and some other feedback from students made us wonder if it was easier for design students to, and this was before we saw the presentation from Senka, it will be easier or more interesting for design students than for fine art students, for example, to work with the CREAMS platform. And we have sort of decided to test that idea in the near future by inviting colleagues of students from the design department and the architecture department. Hopefully, at the same time that we'll have another cohort of students from the art academy to use the platform together and to document feedback of their experience, right? And maybe have some research feedback on how art students respond in contrast to design students. My gut feeling from looking at the output of the students from Shanghai is that they are more amenable to working with not being overwhelmed with the idea of manipulating gridded structures to create unique space, to create interesting bodies. While our students want something more organic of the past. Something else that points to this was then benchmarking the experience with the CREAMS platform with other virtual experiences that they are more accustomed to. There was a lot of reference to Roblox and a lot of reference to Minecraft and how the affordances and the gameplay in those virtual worlds and the kind of interactive is kind of more intuitive for them. Now, while it's understandable that CREAMS is still being developed, so you can't compare to Minecraft that's there for like ages. And it's also interesting that it's not like Minecraft really gives you such a sophisticated UI in that sense. So I think that's something to explore critically from the user experience perspective. You know, that what is it that will make students think that Minecraft is a more intuitive user experience for them, even though it's not like flashy or really refined to look so cool. But they seem to be struggling with CREAMS. And that's also made us, and I think this is where I have to come, that also made us go back to think about the tools that we have also had to, that we use regularly, and we introduce the students interestingly, it's not the most easy tool to get to. We complain a lot. Even we that have to introduce it to people, we complain a lot about it in terms of difficulty of building. But it is actually eminently useful in action for what it does. It's not a 3D tool, so it's super useful, and I think when Annette wants to do it, you might be able to pick one or two ideas on what can be used for. In this case, that's really for an artistic context because research technology is really focused on artistic research. It does tick a few boxes in terms of the final output, like the original intent of the tool. So for us, going through this exercise of saying, okay, what works in research practice and what do we consider to be problematic or what do we consider to have failed? I think working backwards from that, okay, if we were working with a vector tool, that's what we want towards finance students likely to buy in a vector tool. I think that is an interesting exploration, which we also might want to extend for that this immediate conversation to maybe offer to the group in a more structured way. Yeah, so that would be the constitution of invite our next one.
Okay, thank you. Maybe only also to add to what I just said with the fine art students, I think there is something we also called in our report. There's a term called transposition. I think that is quite crucial, and I think it matters even more in the moment when students are dealing with their own work they created. So there's a huge difference to implement even 3D models or plans, architecture plans, or images into that virtual space. So I think the feeling of that there's something happening that doesn't represent what you want to represent. I think this is less than when they create not only it's not only paintings, it's all kinds of artistic expressions, and there's always it's difficult to transpose it into a digital space or in a virtual space, and I think there is something with the virtuality and this transposition, and Rebecca also. I know that you keep mentioning it also in relation to curating, so and also in relation to the virtuality actually. There's something to keep in mind. But to briefly go through a few examples of the research catalog and also to understand what it is. So you can see probably now it looks like a website. It sits. It comes from the Society for Artistic Research. It's about 10 years old, and some things really feel also sometimes heavy, sometimes old. But what is interesting, and it sits in a larger community of institutional partners, and of course. Relating it back to CREAMS, CREAMS is starting. There are a few partners involved, but I think that's also crucial to make that grow slowly. Interestingly, also with the research catalog, the Society for Artistic Research in this the notion of artistic research is something that finds a kind of platform and to get an idea how how different it is. What can be done with the, and just to read it out loud here, the research catalog is free to use for artists and researchers. It serves also as a backbone for teaching purposes, student assessment, peer review workflows, and research funding administration. It strives to be an open space for experimentation and exchange. What is possible is to use audio, visual image, moving image, shapes, and it allows, it allows quite a large amount of data to be uploaded. So it's the big advantage is, of course, also to use the free server space, and the different institutional partners are contributing to keep that to keep the financing alive. And just to give you one example that is related to a course that is called Artistic Entrepreneurship. And we can invite students to collaborate. So that's another thing that became quite obvious when we tested CREAMS, that they were immediately looking for a room that they could actually work together in it. Instead of every student is assigned to one room, and then there's like a teacher at the top assessing what they're doing, and we always had this emphasis on like working in the same space together, literally, so to speak. So it looks, all the pages look quite different. There's a long line that looks, that brings audio, like a narration. One can scroll horizontally, as long as it's needed, and vertically as well. So it's like a display. It's a sort of mapping that is helpful to do. To go back. Then this one looks very different with features popping up if you scroll over. And attention economy. Okay, 1 second. This again, just to give you different types of a look. That is again a very long, it's a lecture that is stretched over and like annotated according to the moments of the lecture, together with slides, and it just goes in a very long horizontal line, very interesting about maintenance actually and computer programs. So it really scrolls quite far, and the audio button is possible to stretch accordingly. To give you 2 more examples, there was again a project together with students coming out of an experiment in a small village Spain, and the assignment was called Labor in a Single Shot, and we had rooftop screenings, and this was like the translation from the works in that kind of platform. So as you can see, it's just a very large photograph, but in that is a kind of map, and in that map is again like videos embedded. And then you can just follow the different lines. It goes up and to the side again. So yeah, just to give you a few possible examples. And this was built in like a collective effort. And then at the same time, as it was written, so what is useful for in that platform actually that it's accepted to hand in even dissertations. So and this has to do with the different levels of publishing, because there's one final step of publishing. One can work on its own, like which is then invisible for others. It can be visible for only the collaborators, and it can be made visible for a larger community. And then there is one level of publishing that means it's like similar to send it to the printer. So you, in the moment you publish, you cannot change anything anymore. So it's like a closed, and this makes it possible. It gets even an ISBN number. It can get into a library system, and it's accepted as a handing in a PhD, a master thesis, and so on and so forth. And it really works on all these different levels, which is quite nice. And if you explore the different researches, it's also just a growing community, which is a huge database also that's of course coming together. Again, one more a huge map with students had to bring examples to the table, and out of these different examples, we created an imaginary map that again goes in horizontal and vertical directions. Yeah, and then other pages where the students just worked independently, working with uploading a video, making a sound piece, having images. So yeah, and just to really give you a very brief input, and the reason why we're mentioning it on one hand, as you said, it's quite helpful for teaching. It can expand, and the open question is what can be learned from it, or what are the features that could be implemented in the platform of CREAMS that can do other things. And other things are still in baby shoes. So yeah, that's maybe our short contribution to that. Happy we can take the questions. Or Arya, do you want to add something, maybe?
Yeah, maybe just to reinforce the point that, so while research captures are proven to be very useful, the user experience or the experience onboarding people to use it is very painful. We ourselves often get confused for people that we try to get to use it. So, and of course, it's very specific to a text-based kind of approach. So we use multimedia, both video and sound and all that. While we're looking at to kind of ask ourselves and try to figure out what makes it so useful, and try to answer that question for things as well, and then to ask, what would we wanted to have implemented to make this less painful to use, and also sort of try to find answers to the question we asked, that what should it mean to create exhibitions or expositions, as they are called, research in three-dimensional space, and especially with what's currently available on the display, what's likely to also be more developed in coming years. Those are the questions we're asking ourselves, and yeah, thank you.
And one more funny thing is the people who in that platform complain the loudest are always the designers. So they're used to, I don't know, then they try their InDesign knowledge and it doesn't work, and then there are a few features, and then there's more that they're used to and you cannot zoom in and out. So, and then instead of zooming in and out, you have what they have, this kind of navigation, and but you can move around on that navigation. So it's really partly counterintuitive, and I also proposed earlier that to introduce or promote actually a new platform to students, to say embrace struggling with technology as a feature to learn. So to instead of shying away, and of course that's also happening on a massive basis. The gesture is always like this. So in the moment there, how do I use it? How do I? So it's to reintroduce the complexity and also the heaviness, and also to the non-easiness as a not only as an obstacle but as a feature. And to combine it with an awareness how these things actually work. That could be another, yeah, it's part of introducing these things. So yeah, it's maybe, and there will be always people who complain about whatever. So it can be also not the basic, but yeah, it's really important where it's embedded, what it does, and so there are a few steps, I think, to learn from. Yeah, so but I think that's it from our side.
Thank you, and for comments and for presenting us with research pattern that you have. It's difficult to hear myself. Marino, can you? I'm sorry, we are listening to ourselves twice here in this space.
Yeah, it was not expected that you will, but okay, now it's...
I want to comment on something that you mentioned, that you might be willing to check how art students versus design students react to the CREAMS platform, and I think it's a very interesting point. And I heard your comments about some students having a lot of difficulty to comply and integrate with working with the platform. And actually, my students are here, so maybe they will say that it's not correct what I'm saying, but I felt that they very easily integrated their work into a platform that gives possibility for creating three-dimensional space. And maybe it is because they're coming from more an architectural / designer background, and they work already with digital software, much more complex than the CREAMS platform. They work on Rhino and Revit, and even using parametric tools, which incorporates coding within the three-dimensional planning software. So for them, I think you guys, they got guidance for like an hour and a half, and then they took off and the platform is a prototype, it's a beta version, so there are some problems, but they actually started working on it, and I got some comments from Mario Stel from Cognitive UX that he was surprised to see things that are possible in the platforms. For example, some students put elements, you can only assign elements to the wall, but students moved them into the floor. So they became incorporated into the floor, or the ability to upload three-dimensional objects. Instead of just uploading artifacts, they thought of creating partition walls, textured partition walls, and creating subspaces in the 5-to-5 modules. So I actually found that the students from architectural/interior design came with ideas on how to overcome the challenges or the drawbacks of the platform, things that we have not developed yet, and actually create spaces that can serve their purpose and their vision. Maybe not into 100% of what they envisioned, but they didn't give up on what they wanted to do, and try to work around things that are not possible by making it possible. So actually it is a very interesting research, and I would be happy to bring in our perspective, because we mainly work with students from interior building and environment design and curatorial studies, which deal a little bit with spatial design, but not so much with the art students. So we could maybe extend some study on this together.
Yeah, it sounds interesting, for sure. It's really it's like a different priority. I mean, of course, if we also have courses that are more interdisciplinary, and they work on a certain subject, and then they could be told, okay, make an exhibition on this and that, for example. And then it's already a different framework, or make an artistry approach exhibition, for example. So, but in the moment, it sits in their kind of to get them interested in using it with their own artistic agenda or things they do. Then there's a huge gap. So that's also really interesting. But yeah, we have to figure out. But a lot of them are also just in general reluctant to anything related to computers, related to the digital, and so on and so forth. So it is, it's really different. Yeah.
Yeah, and I think I did like the way you framed what the students did with CREAMS in the way I interpreted to myself that they hacked the tool, and through that hacking of the tool, I mean the students at Schenker, through that hacking of the tool, they were able to sort of create feature requests. You know, like, okay, this is not a feature that exists right now. We found a roundabout way of doing it, but it now, obviously, it's going to be more useful to us if we can actually make it a feature. And I'm sure that would be really helpful to the developer. I think that will also be an approach that we should adopt. The idea that we have that, okay, we need to set this as a task, that you guys, we need you to approach this tool and be ready to wrestle with it. That wrestling with it is part of the task. We need to challenge you to struggle with this tool and let us document what your struggles are. And then if you manage to hack it in any way, then we document what you hacked, and we create a feature request out. So it's a way of teasing out, you know, and also I think it could be an interesting research question, like you said, for us to track if there are differences in how art students and design students, you know, use the tool, and maybe, you know, that could also influence how the features are, either what features are provided or how they are contextualized in the tool, how the UX allows people to know what they can do. So I think it's been really useful to see the output from Schenker, and it's reinforcing some of our thoughts of what we think we can further contribute to our project.
Any other comments? Any other comments from the students, colleagues? No? So, Annette, well done. Thank you very, very much. I think that Marius got today a very good response, starting from the improvement of metadata, accuracy so far of the quality of the models, and of course all the bugs and good advice for the improvement of the platform for the VR presentation. So now I have to check when the coffee break is, because we are going to have a hands-on exercise. I don't know how we will handle it with our colleagues abroad. They cannot follow us. We don't have now here the system so that whatever we are going to do, they are in the background to follow up and of course to you know, exercise with us. Huh? Therefore, I'm asking those online what they would like to have. I think that it's better if we interact with you online, remotely now. Marius, Rebecca, yeah? Because we're going backwards, yeah? And each one of the fellows or of the participants here have to follow up. This is what I'm going now to do, is a very, very short one video clip, 3 minutes, 3 to 4 minutes of a digitization, which we did, and it's all about photogrammetry. And because the students are coming from the Faculty of Architecture, Arts, and so on, and using tools like Revit, like Rhino, and so on, it's interesting to see the pipeline and what exactly photogrammetry means, but also digitization. Okay? So, therefore, yes, Panagiotis.
Quick note.
Let me just only find the video while you are talking, Panagiotis. While you are talking, yeah? I'm not, no. While you are talking. Sorry. Because I have to find them. No, Panagiotis, please, go ahead.
Just a quick question in terms of the time slots. I was under the impression that I would go on with the outfitting. So I guess that's after the coffee break, so whatever suits.
Yes, the coffee break, Drew, at what time is the coffee break? Is it now? No. It's not now, because I need just only 5 minutes. I will send out the message, and then we go directly to the start working using our... Yeah, Panagiotis, okay?
I understand that we're going to have a hands-on thing.
Yeah. No, just only a video clip now, and then a coffee break, and then we will continue with the hands-on. Here, practical exercise, how to digitize.
Mr. Ioannidis, when do we present the RFA results? The project result 3 presentation, when do you want it to take place?
It's I can do it even now, but or even later, but that's not the issue. This is what I want, because we have also tomorrow the time. And the point now here is to give to the students something in the hand to understand and to use. To use in the correct and appropriate way, so that their results are not just only for the show, but for the real praxis to be used and reused. Okay? That's what it is at the end of the day. What it counts. Yeah? Okay? Do we? Okay? So, now let me share a small video. So, Panagiotis, can you see it? Can you see my screen?
Yes, I can see some title.
Yeah. Okay. So now, you are in Limassol. Limassol is a bicommunal city. Okay? It's the second biggest city of the island, and it's a bicommunal. Bicommunal means we have Turkish Cypriots and Greek Cypriots. Okay? The area where we are now was the borderline, more or less, there where the two communities were living together. Farther to west, beyond the marina, of Limassol, it was the borderline, the real borderline between the Greek and the Turkish community. This borderline was a street, a road. And it's so famous that, why? Because there we have two very important monuments of the two communities. One for the Christians, for the Greek Orthodox, the San Antonius Church. Those who are staying in the Befkos Hotel, they see both monuments because it's on their way to go there. And 200 meters across the church, but on the other side of the street, is the mosque, a very important mosque and a landmark for the Muslim community in Limassol. Now, the city asked us, please digitize, okay? And give us, hand over to us, what? The drawings. But the structure, which you're going now to see, the landscape, is not so easy, and it takes a long time to do it in a terrestrial one way. So therefore, we use both a mixed approach with a UAV and a laser LiDAR scanner. Okay? So now, let's...
please explain a little bit.
Wait, the video is talking. The video is talking, Rebecca. The video is talking. Okay? And then we'll interact. This is Cyprus. Okay? We are now flying from the space down to the ground.
You need to share sound.
And here, no, there is no sound. I'm talking. Here is the mosque. You see? Here is the street, which is splitting the two communities. Where is the church? The church is here. Okay? 200 meters across. The municipality asked us, please digitize and deliver to us the drawings. Now, how to digitize? Because that, what I am now showing to you, it's something that we are using for the students for a hands-on exercise when we go to the field. Okay? To know for the first time what a photogrammetry means. Okay? Now, let's start. Have a look. Now, these are the photos coming from where? From a camera. and the camera is where? On the UAV. Okay? UAV is flying. These are real, yeah, this small helicopter. Okay? So, now, what is happening here? We try to find common areas in the different photos. Photos. Different common areas. Which are these common areas that you see here? They are the 3 red points. Now, a fourth image is coming. The UAV is flying in an elevation given by the pilot. Now, a fourth one, and you see now here, we have 4 images, 2, and another 2, and the software detects what? Common points. Those common points are here. 1, 2, 3. Of course, more common points are coming in, slowly. So now, if we take all the photos around, what is happening? Ladies, here. Gentlemen, here. That's photograph. What's happening if we find more common points from all the photos? Using what? The triangle principle. It's a triangle principle. It's a very, very simple trigonometry used here, out of which we reconstruct, okay, on the 2D and then in the third level, dimension, space, the XYZ. Okay, what's happening now? Have a look. The UAV is flying, creates images, image acquisition from drone, flying around there, and SFM, please write down SFM, SFM, S like structure, F structure, F for M motion, movie.
Structure,
form,
motion.
For, not form. For you, for me, for the God, for our friends. F-O-R, not form. Structure of motion. Okay? I'm creating a structure by moving around. Okay? Meshing of the results of the point clouds. And here probably you heard about Platon, you heard about Euclid. Platon, you heard about Platon? Plotinus, okay? Platon, he was a philosopher but also a mathematician, and he was the inventor of the first academic institution in the world, not a university, academic institution. Outside of Athens, the first one. He had a student, a very famous one, mathematician, worldwide, Euclid. That's the reason of the Euclidean geometry, Euclidean algebra and so on. That comes from this guy. So, this guy developed a theorem which is here now in what? 2,300 years ago, okay? Euclid. On Euclid theory, we had another one guy, a Russian one, who decided, a mathematician named Voronoi. In his PhD, okay, he extended the Euclidean theory, okay, and he said instead to take 3 points, a triangle, I can take a 4th, a 5th, a 6th, 7th, 8th, undefined number of points in the space on a 2-dimensional as well as 3-dimensional space, and it works. With other words, the Euclidean theorem, or the text of the book of Euclid, was destroyed, partially destroyed, and only the first part was there, still existing, for the 3 points, for the creation of a triangle. Okay? So, now, this gentleman Voronoi said, we can extend and we can go and create all this what it is today visible in Google Maps or in Google Earth to find the shortest distance from here, when we navigate from the one point, from our location to our destination. Later on, a couple of hundreds of years later, Mr. Delaunay, a French student, did his, another one mathematician, did his PhD. And out of the Voronoi, okay, Euclid, Voronoi, okay, Delaunay created what? The Delaunay, the so-called Delaunay triangulation. Voronoi, okay, theorem is well known around the scientific world. Voronoi diagrams. The Voronoi diagrams are the most important, or probably you heard about the Voronoi skeletons, or Voronoi diagrams. And then the Delaunay triangulation. This what is happening here today in whatever triangulation systems that we are using, or the structure for motion, or the photogrammetric software is Euclid, is Voronoi, is Delaunay. Okay? These three gentlemen. 2,300 years ago. It's nothing new, but someone managed to bring everything together in a nice software which is running and creates these meshes. Meshing of resulting point clouds. So they mesh in triangulated structures, not overlapping triangles. That's what Mr. Voronoi and Delaunay managed to do. And out of that you see here a very nice, well reconstructed area that the owner, the stakeholder, the municipality of Limassol wanted. Now, that's the exterior. What about the interior? For the interior, we are using a different device, a laser scanner, okay? But the laser scanner, from one position, you cannot get all the information, acquire all the information, you use different positions. Now, if you merge all these positions, exactly the same principle as before, okay? Euclid, Voronoi, Delaunay. So, structure for motion, meshing, and voila. And then you see, things are coming together from the interior. If you have the exterior, how now this principle is working, you see? It's a time of light, like now, as I'm talking, sending, receiving, over the time, I can calculate what? The distance. Simple physical rules. So, if I have the interior, of course, from the UAV you cannot capture everything. You need to go also to the ground, and this is what we're going to do now with the nice lady over there, with our camera. So, we have three different ways of capturing. Here the building. First, the UAV. Secondly, the laser scanner, inside, outside, and all this data have been merged together in such a nice way so that we were able to recreate what? You see here, digitization of square of friendship and peace in Limassol, CAD modeling, solid modeling. Now we are here where you are. And if we use also materials, voila, why we need metadata, in the three-dimensional space, nothing exists without materials. And if you have materials, then you have to take into account the conditions of the materials. Because if you don't take the conditions into materials, then you have a problem with the museologists or the curators. Yes, please.
So you are using the 3D scan as a reference to rebuild, because this
meshing all together, yes.
This particular model is after modeling based on the scan.
Yes, yes, yes. We wanted also to know how thick the walls are.
It's not the final product, the scan to take. It's used as reference.
Yes, but reference was also as an input to the creation of the, or to reconstruct the building. Okay? So to create what? The drawings as such. Now, the same also for the mosque. The exterior. The interior. Interior based on the terrestrial laser scanner. The CAD modeling, the reconstruction, of course, just to, you know. So in this area here will be now, it will be now a very big investment. That's a VR application here. The big investment is going to be in few millions, where full reconstruction is going to be, renovation and so on. And that's going to be the square of friendship and peace in Limassol. Yeah? Next time, probably when you visit Limassol, you will see there a new structure around. And of course, in a game engine, Unity and whatever, yeah? Or Real Engine and so on. So, in a very quick one way, before we go for a coffee, the structure for motion, the photogrammetry. Photo, okay, and the econometry. Photogrammetry, and this econometry is based on the triangle theory that you know, the Voronoi diagrams and the Delannoy triangulation, okay? Very simple mathematics. If you sit down and study them, you know what you will say to yourself? Such a wow mathematics, but very simple. So simple that why people manage to write now the software and have such automation in place today, and not on that time, whatever, years ago. Yeah? Anyway, that was a very, very quick one way. We will see it also later. There are some rules that we need to respect. Otherwise, it's not going to work, the photogrammetry. And I mentioned at the beginning, we need to find common points. Common points, if this is one photo and this is one photo, do you see any common points in these two photos?
No.
No?
Yes.
Now?
Yes.
More.
More.
And if we have more hands, and now look, no, more hands are coming here. You see, there are even more common points.
Like a collage.
Exactly. Yeah, of rect points all over the place. And once when you have these chaotic three-dimensional points, what is the next problem? To create out of that a structure which brings a sequence, because it's a chaotic, a sequence, and this sequence is coming because of the Euclid, because of the Voronoi, because of Mr. Delannoy. Okay? And they do it in such a beautiful and a nice, quick way that it's visible in different engines and software today. Do you have Apple mobiles? Yes. Which one, 16 or 15?
12.
No, 12 is not in, but 15. Do you have 15? So in the 15, I think, is per default an application for photogrammetry. Check it. In the other mobile, it's ready to run, is ready to run the Apple is giving that free as of 15, version 15.
But what's the name?
I don't remember.
Actually, there is also an application called Polycam.
Yes.
It's for free. You can scan objects exactly how you explained.
This week it comes after the coffee break. Don't worry. There are several. There are several. But this what I wanted to say is that is that, just a second, ladies and gentlemen, we are finishing, but just a second. This what I want to say is that Apple, no, look, the trend of the future. Now, look, just only a minute, please. May I have your, what is the trend of the future? The trend of the future is that if you like it or not, you buy a mobile, you get a camera installed, pre-installed. This is an old fashion. Now you get even, and that's the way how Apple is showing, you get also an application to use your camera to do what? Not only photos for 3D. And once when you finish with your photogrammetry, with your, let's say, 20, 30, 40, 50 photos, you know what you're going to do? You push a button, and this application is creating for you a 3D model. If the 3D model is waterproofed, and I will explain to you what waterproof means later, this is what it was in your 3D model here, not the case, because you had holes, yeah? Visible, open spaces. In our volumetric and waterproof model, there are no holes, okay? So that's the way, this is why we say waterproof. Waterproof is we put water and it stays there. It's not coming out, like a bottle of water that you have in front of you now. So, now, taking that into consideration, once when the model is completed, you push another one button and you know what is happening? You send it to the printer. And the printer is where? Somewhere in your house. That's the trend. And you will see, not later than 5 to 10 years it's there. And you, as a country, Israel I'm talking, you have also one of the leaders in manufacturing of 3D hand scanners. Matrix. We bought one. It's over there. We brought it even with us to show it to you. Yeah? Which is working like, you know, painting. Like painting. You go up and down, and it creates automatically not only the 3D, but also the triangulated shaded structure. Okay? So, that's for the moment. We break for a coffee break. Gentlemen, dear colleagues, thank you remotely. Thank you very, very much. We will be back again online or not later after the coffee break.
Want high quality, high precision stuff for creating digital twins. You go with something like this. I don't think that's necessarily appropriate for what you're trying to achieve. Okay? The principles which we'll go through are the same, but you can do it with a phone.
Thank you.
Okay? So, we were just talking about photogrammetry, and how we do photogrammetry. I explained this to you already. If you're confused about what that is, it relies on the Carriage principle. If you do that, close one eye, join your fingers up, and close the other eye, one of the fingers will disappear. Okay? So we take two photographs, 1, 2, we find the difference, and we join the dots. By Mr. Deluni, Euclid, Veroni, et al. So that's all it is. And with laser scanning, we know what the constant of light is, so we chuck a ball against the wall and we catch it. And the time it takes to land, we make a dot on the ball. Then we chuck it again, we make another dot with it. So photogrammetry is the easiest way. You can do it with your phone. This is the legendary head of Venus, also known as Aphrodite. Your question yesterday about fidelity and what is authentic. This is a copy, this isn't the real one. I have asked for the real one, but I've been told no. Which kind of offends me, you know, as a digital archaeologist, I have to work on Earth-as copies. But nevertheless, there's also, I have to say, problems with this. This is not an ideal case study because it's all white. So one of the things which photogrammetry needs, if you think about those dots, is it needs to be able to key into something to tie those 2 points together. And if you've got a white object and a white...
No contrast.
Ah, that's why the platform has dots on it?
Exactly so. That's why this has what we call targets. If you're doing it in the field, so my background is in archaeology, digital archaeology, and I live back in Pompeii and Herculaneum. If I'm doing something on site, I carry around a box, a little bag of coloured dice. Yeah, just a little D6s if you're a geek. Nobody's a geek. Okay, so you take them, they're coloured, put them around, it knows what they are. If you're doing high definition shots, you might even get the dots on them. And then they're easy to cut out because they're white. Another quick and dirty hack is to put down a sheet of newspaper. Put the object on because newspaper gives irregular things. So this is the lazy Susan method. Okay, so we stand still and rotate the object.
It's not a problem that all of the points that are the same color? Like, how is it gonna...
They have different shapes?
They're all kind of the same. Oh. I mean, not exactly, but... this
kind of the same.
They're not the same. It's different.
They're different enough so that the...
So it works even if the object is transparent?
Will come. Okay.
So if you're scanning a building, you have windows, so what's happening?
It won't come out.
So it's going to be like, it's going to be like a picture of what's inside? Like what's going to happen?
It will ignore transparencies.
So it will be a hole.
It will be a hole.
Sometimes you get
But when was the
noise
reflection?
from the reflections, and
Yeah.
the noise is geometry which you don't intend it to be there. So sometimes you have some noise, or sometimes here, like we have the shaders, so you'll get the shaders behind it.
So you get like an alpha, as they're fighting on the algorithm. Well, we don't know which one to do first, which is a technical rendering issue, but that's like. The other things which are very difficult to do are anything that's very fine, like hair.
Oh, mirrors.
Sorry.
Anything that's reflected, like a mirror maybe?
No, mirrors, yeah. Anything which breaks up with diffraction, like CDs. The light comes in, and it just goes, I don't know, it's just random. Photogrammetry is one tool to use, and the reason why we sort of do things like laser scanning, white light scanning, depth map scanning, which is now called LiDAR on the phone, which was pioneered by CREAMS, which is an Israeli company, which is bought out by Apple, which is why Apple now has the technology and held that back for at least 10 years. Not like literally twisted it, advancing the state of things record things. So that's why we use all these different technologies to try and bring them all together. When we bring them all together, it comes back to the question about what's original and what isn't original, and that's a deep philosophical conversation. What we create is representations of a truth, and then we need to justify that truth. Which brings us into another longer conversation about paradigm. So this is the lazy Susan method. We have a lazy Susan, cake stack. Where you can rotate.
Isn't the light sometimes tricks us about the shape? Because there are different ways to light an object, and sometimes when you light it in a specific way, it's difficult for us to understand the depth.
Yes.
So what's happening with photography in that situation?
Okay, so in this case what we're trying to do is to get the most even light as possible. So try and knock out things like shadows and any of those tells that we psychologically build up. You've all seen the optical illusion of the face, and then it moves a bit and you go, oh, it's actually going in, it's like a jelly mold. Yeah. So what we try and do is eliminate that by putting in lighting to do that. On the other hand, sometimes lighting can be really useful if you've got low definition and we want to bring it out. Sources for courses, there is no perfect answer. And that's part of the skill and the art, as opposed to the science of the photogrammetry, is to be able to go, okay, that needs a little bit of adjusting, is lighting, doesn't need lighting. We might have to walk around the object.
Yeah, because for example, here there is a saddle, but if I have a light underneath me, you will not be able to understand how deep my eyes sit or if this is behind my face or not.
Yeah. Plus, if you get a torch and you stick it under there, you look very, very scary, and it might not be the desired effect, or not. Yeah. So faces are really problematic anyway because we're.
I understand because of our standard.
But you're quite right. Because we have X billion years of evolution on our side. We're very, very good at understanding faces. That's kind of what we're geared to work with.
It falls in the uncanny valley. If it's not exactly.
Yeah, it is. It's exactly the uncanny valley. And you can look at a face and go, that's not right. Yeah. If we look at theatrical masks, so Greek theatrical masks or Japanese no theatrical masks, is with one tilt and the whole expression changes, depending on where you are. There's some really interesting studies on that. Should we try and focus? Okay.
Examples, with literature, with all the different, let's say, devices to digitize all the complex whatever objects exist in glass, jewelry, caves, underwater, whatever, okay? And there is, automatically you find everything. You don't need anything else, because in the big report, you have a very big list of 400, 500 references in the literature. The state of the art, it's there. So with these two documents, this is the short, and the other one is the big one, yeah? You have everything so far as 3D digitization concerned. You don't need to go and Google and search, or you go to YouTube or whatever. Now, that's the number one, sources, knowledge available. Second, most important, you digitize thing as a human. I want to see something, how I see it. How do you see it? You want to see something. How?
You go around.
Exactly. And not only around, you do this, exactly this what you mentioned earlier with your eye and so on. Yeah? Because you want to cover everything. Yeah? So, exactly in the same way is how the photogrammetry, it works. This is what I see, this is what I get. This is what the camera can see, this is what I can get. If I don't get it, and I see my 3D results holes, yeah? Holes, it means what? That there are triangles, you remember? The Lonoid triangles. And those triangles, the vector, the normal vector, is not showing in the direction to me, to the user, showing in the other one direction. Okay? And what does this mean? It needs to be a correction. And what is this correction?
Taking more pictures.
Exactly. It was not visible. It was not a real good, high quality capture of data, digitization. So, having that in mind, let's go to the next level, which is what? It needs to be in all over the areas which I see, what? The same light structure, density, okay? More or less in an interval, more or less. No dark, no very light areas. If I have a homogeneous one, it's perfect. If not, okay. If you have areas which are black, What is the problem with the black color?
You cannot see that? You mean that?
Yeah. It's a problem. Black is always a problem, isn't it? Even if you see a human with black clothes, then you must hear something is wrong with that person, isn't it? I don't mean it with you, yeah, but I mean it with you, but you know, a good friend or whatever you're asking, something.
Someone else, not
yeah. So, therefore, also the colors are extremely important. Okay. So, having that in mind, let's start now, and we go. Having again, this is what we said earlier. Who corrected me earlier when I did my statement?
Collage. That's the collage.
Yes, the overlapping. The overlapping.
Yes.
If I want to have common points, okay, then it needs to be somewhere a common area and a very good overlapping. There is in photogrammetry a non-written regulation which says a high quality of digitization comes out as a result of over 90% of overlapping. 90%. You know what it means, 90%? It means a long,
it's moving very slowly.
yes, long time to go around if the object is very little. Or the UAV is shooting because it's flying, cannot move slow. So, having that in mind, it doesn't mean anything the resolution. Why? Very simple. This is what I do always to my students. Pay attention. If I use my mobile, I have a camera here. Let's say the camera has a resolution of 4K. Now pay attention. I'm standing here and I'm doing a photo. Okay? The resolution is 4K. Moving a meter here. Another one photo is 4K. The resolution here is 4K. Here is 4K. I'm focusing on your face. So, resolution here, 4K. 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 I'm not making a photo, but I'm just only saying. What is the difference? The resolution is the same. Okay? Same camera, same resolution. Because a lot of people are saying, what was the resolution of your data acquisition? Say, 4K. Ah, wow! High resolution, high accurate. But you know, yes, but they never ask. From which distance? Ah, it was 2 kilometers up. So, you know, the difference is that I capture a wider area from there and approaching now here, making the distance up. Just only the face. From there, here, there is a big difference. Okay? So therefore, if I'm capturing small objects, like the artifact that we have here, two very important parameters. This is what we use, the word parameters. The first one, the distance, lighting. Okay? As an added point to this, what we said earlier, all over the places, I have to go, okay, from all the different point of views, I have to camera, I have to make my capture. So having that in mind, and the overlapping of 90% and above, we are covered in a very quick one way. Yeah? And let's the music start. Who wants to be the first? Who wants to be the first? Who wants?
So with the camera?
Yes,
of course.
Go to your side, please. Thank you.
Just to take the
camera. Okay, yes.
Just
yes.
to take photos like you explained?
Yes, but we need to focus
we need
a
to
little bit
zoom
more.
out a little bit because our hair is cut.
Oh, the hair is cut, yes, okay, no problem.
No, la tua dal cima attaccato.
Why not the realization in one? That's okay. But even this is too much because we don't need now the entire, you know, study to be in the photo. It's okay if I have this part, then this part, then this part, and this part, and this part.
Okay.
You make pretty
Yes.
point.
Okay.
Yes.
And you need
Okay.
to move
now.
Sorry.
Is it the problem that the camera doesn't see your
Yeah, I was gonna
No,
say,
doesn't
because
matter.
now if I go like this and only take
Doesn't
part, then we don't have the points that
Exactly,
Drew talked about.
exactly, but
So
we
this
are
is-
not interested
so
about these points here, about the markers. An automatic procedure from the software. The
Okay.
software
This
is
is for
detecting.
manual.
Yes, but now we are trying to do our first test. And now our first test is, Pambos, come here, please.
I'm here.
Let the boss do the,
What
you know.
So you find which area you want to
We are
start.
adjusting the
For
camera
example,
in a
if you start from the
professional
top,
way.
Yeah.
sorry, no, tripod is not so
We
good.
should. Okay?
You start,
From
sorry,
this point, if we're going, you need to look
first. Then you move
Yeah.
a little bit, check, and you have it, start, make the
So this is and
bubbles.
ancillary metadata.
Don't move your hands, me.
Para-
No. Put your, make half scale, yes.
I'm sure we'll later say. Para, aside. And that's things like
Now, what is the problem? What is the problem? What is the problem?
What's
The
in the
problem is
cover?
that, you know, it's part of the head. It's part of the head.
taking a random and seeing the photographs, let me see
This is from my mobile. This is Liber. This is one of the most important poets of Cyprus, coming from Larnaca, and his whatever is in the archive of Larnaca. So when I visited 2 weeks ago the archive of Larnaca, I thought about the CREAMS. This is extremely important. I visited the archive of the city of Larnaca, the city where the airport is, okay? On that archive, you will find content of two-dimensional, three-dimensional, from photos, from newspapers, books, but also artifacts. One of these artifacts was the one that you see here on the screen, and it was from a very, very important person who was born in Larnaca. This one of the most. I took my mobile and I did a very quick scanning with my mobile. But we had a problem of what? Lighting. It's an archive. It's not a place to scan. Yeah? And now, you see automatically, come closer, come closer, come closer. You see? The different, but then suddenly the colors are changing. Shadow is coming in. Yeah, shadow. Yeah, and this shadow is reflected to the 30 lens of my mobile. Okay, in a such a way that from a dark in yellow. Okay, but it's good because at least with some yellow you can do something. Software can create something. Anyway. I started here, you see here, directly, this level, move around, and all this. And then suddenly I use my mobile above, and so on, and so on, and so on, and so on. And then very soon we will see what's happened with the 3D, which I sent him using my 4G from the archive to draw the photos, asking Drew, please interrupt your work, let the software run, and let's see what comes out. Okay? And he's going to show to you. That was 88 photos. And I did it in a very, very quick way, without any, preparation, without anything. I was surprised to see something like that in an archive. Okay? But I said to myself, okay, that's now the opportunity. Can I make a copy? Can I make a photo from this? Yes, okay, you are allowed. IPR free. Okay, voila. And I did it. Okay?
What software are you using for the photography?
So we've been running trials on 3 different pieces of software.
Which is a part of the discussion tomorrow at Soria, because we had a long discussions with Marius. What is the best software to be used for the SFM, structure for motion? Okay? For the photogrammetry. And there is where we want to give you some of our expertise here, so that, let's say, don't use this software.
don't use this software. And why? Because of that. Okay? You take that with you tomorrow too. So you can continue. But here we need to continue here too.
Okay.
We need a code. We need a card.
A card with magic. Don't worry.
I'll try and work out which ones are the best. Sometimes you use the right tool for the right job. This one is person.
I have another patch for you.
No.
Yeah, we can get prepared. Carlos,
Maybe it doesn't matter. את רואה כשאת מפקסת כל פעם מחדש, זה לוקח יותר זמן. אם תעזבי אותה לחצי. זה פחות.
גם יש עוד בעיה שהיו אבל לא בעיה.
So it's trying to interpolate that information. If you've got textures hide a lot of sins. Unfortunately, because it's using bringing in the texture, there's no textures there. It's just pulling additional information.
Because of no correct, like